Hi, I'm Chris from Airwindows, and it's another live stream day. It is Tuesday specifically. I am hopefully going to have stamina for doing this today, even though I had to run around lawn mowing and stuff earlier and getting a load of firewood delivered. So that bodes well for the upcoming winter, or indeed fall, or if it gets ridiculously cold again in spring and summer, because that's been happening too. And let's see, going to bounce over to display overlay because we're playing with Godot Engine today. And I'm going to jump in and maybe fool with a couple of these things I was thinking about. Possibly including resizing this window so that it fits onto the screen properly. That might be good. Got there. Pardon me. It's possible that I will end up being more coughing and not doing well today, because when you mow the lawn, and I am trying to replace my lawn with micro clover. I don't know if that's actually going to work, though. It's just something I'm trying to do. The particulate matter that you stir up and then breathe doesn't necessarily do well for you, and I think that's something that happens to me fairly often. Drop love, hello. In fact, I think that's probably one of the reasons I hate lawn mowing so much, apart from just growing up with it being a big terrible. It's weird how things like that work out. I have gotten over hating trash taking out, but that's because I grew up where it was like a dreadful punishment, and that was carried on even through power of example, because my dad hated taking out the trash so badly that you'd be squishing it down and not wanting to deal with it. It's a grown-ass man, too. So lawn mowing is one of those things, but I also don't like it because grass is not actually very good for the environment. And things like pollinating insects need all the help they can get, which they do not get from lawn grass. So I'm going to try to replace it with clover, and it'll take a while before I know whether that worked or not. What we're looking at here is the Godot Engine and this program, which I can run and show you. Here's my Into the Matrix program again. This is the reverb algorithm generating thing that I've shown before, talked about before. There's a bunch of little changes that I might want to put in, up to and including maybe changing the size of this window, because I've taken to running 4x3 in a little grid of them, and that gives me more vertical space to work with. I fit these controls in here. I haven't been using these very much. They're basically how much it goes by certain parameters, and I'm probably going to look at changing this bottom parameter today because I've thought of something new to do with it. And yeah, well, as long as I am up and rolling, I will make chat bigger. Also set it to live chat rather than top chat, because as a rule I do not need YouTube telling me who I should or should not see. And yeah, so it runs like this. If I hit the 6x6 button, what we're getting is a series of possible reverb algorithms as depicted on the side here. And what you see there in the green are plots of the density of various effect returns, like reverb returns. Because what a householder matrix is combinations of delays in which you never get to hear one of the delays all by itself. If it's 6 by 6, you only get to hear a string of 6 delays, and only then do you hear the output. And the 6 delays in question are every possible combination of the matrix. That's how it's made to work. And what I've been doing for years by now, I guess, is working out how I can first plot that out, and that's what we see here. And then run a program, such as this one, so that it will grind its way through many, many different possibilities. Like right now, we're looking at those numbers going up, and the top number is the number of total possibilities that it's tried. So it's about 5,000 since the time I was talking over it. The bottom one is how many since we last updated the image and the text in here. And the idea is find the best one, but there's been a twist to that, and I'll quit out of here. I was posting on Blue Sky a little bit about what I've been going through trying to figure this stuff out. We've got these methods for evaluating things, and these methods for reading these things. I'll show you what that's referring to. It's referring to this. So this is the bit you can see, and these are the ones that you can't. There's buttons here, which you never see, but they're used by the code to print out one of those outputs and then go back in and continue running again. This button has a script associated with it, which is, if I go to a node here, I think it might show up, or perhaps not. Yeah, the script is search 6, and so we run the program built into that. Each of these has its own script in the bottom, which you can't see because my image on the screen is covering that up. Yeah, I hope I get to breathing better too. Honestly, having discovered that it's probably allergy type stuff, and I had a sort of local crunchy granola doctor, like a real doctor, but leaning towards more of your alternative medicine type stuff. But her suggestion with me coughing all winter was that I should look into early generations of antihistamines, such as like if you get Benadryl or the equivalent to it, that can have more effectiveness for some people than later developments, but it will typically also make you sleepy, and so you might take that at bedtime. And turned out, doing a couple of different kinds of early first-generation antihistamines fixed up my coughing all winter long, which is probably caused by particulate matter from the wood stove or the dryness of the air or whatever. And I am trying it on spring and summer issues like having to mow the damn lawn and then inhaling a bunch of grass particulate matter, I guess is what ends up happening, which is not great, but I feel like it actually works fairly well because it would be addressing the same thing, that doing certain things causes my histamine system to flare up and then I'm sick. And an interesting thing about that regarding basically just being human is I'll develop an enormous loathing of something like mowing the lawn if I can reliably identify that it makes me sick as a dog and I can't do anything for days afterwards. Like, if something is nuking my health, I'll probably take a dislike to it. And that's not necessarily like with regard to hopefully not getting sick over doing that. That would be a plus. And learning that you can plant stuff like microclover and replace the grass that is not good for, that, as Droplove says, it's a display of wealth, it's a display of suburbia, it's a display of a bunch of things that I don't respect. And apparently you can plant clover and that works too, but you can, if you let clover grow taller than it normally would, first of all, it doesn't actually grow very tall, but second of all, it's pollinatable, so you can like feed bees and stuff that way. And yeah, I had no idea what kinds of mixes of weird plants people have as ground cover. It was a new world looking into that, being like, oh, you could plant this? Wow, here's a weird blend of things, which is like grasses and stuff, so that if you have large acres of land and you don't want to do a lawn mowing, maintaining type of thing, you can plant it with this stuff and it's all wildflowers and such. So that's neat. Yeah, the thing, Tabs, your suggestion of the dehumidifier that does things is not what I would be using in winter, because a wood stove dehumidifies so aggressively that it becomes like unbearable and not conducive to life. You wind up with air that is so dry that it kind of creaks, and you don't thrive very well under those conditions. But yeah, I'm talking about all of this various stuff. This is, for instance, target seats, but then this gets updated as the program runs because it tries to identify whether you're specifying a size, a number of seats that the room should be in. It'll chase a number that it feeds into the algorithms that will give you this target on the output. So this is the unseen version of seats that will end up being like, if the algorithm is not doing a very good job of delivering the sizes that you want, maybe this one up here goes to like 1,000 or 2,000 if it turns out that that's what it takes in order to get the results that you thought you wanted. And yeah, oh, also HEPA air filter. I inherited an air filter that my mom had and used. I've actually replaced the internal filter on it since I did that, and I basically keep that running in my bedroom. So yeah, I very possibly don't need to run it literally all the time, but I kind of do anyhow. It just kind of keeps whirring along. And I think that's generally useful. Back to Godot Engine. So I mentioned that these two controls that say seats on them, target seats and regular seats, try to deliver a room size. So the problem I was dealing with earlier, and I'll talk around this a little bit because I'm kind of working my way towards making a series of changes after having made lots of changes in recent days on this program. It may very well end up finding its way to GitHub. We've got all this funny stuff, like for instance, these are the literal constants that end up getting printed on this screen, this being a big old text box. But what it's doing is it's reading all of these and printing them out. So when it starts up, it starts with its best guess as to what numbers should be and starts generating reverb impulses. So what was happening was I could run other things, like for instance, I'll run it again, and I could say things like, say, give me 900 seats and give me a 4x4 matrix, and it'll run, and it'll start generating stuff. And what it's doing is it's determining a score. It's trying to go to the best score yet. It's plotting out which the green dots on that little screen are now normalized to the brightest one being full green and then everything else being lesser amounts of green. That's something that I did recently. Before then, I was having to custom adjust each of these buttons to a relevant level of green rather than pick something out. And you'll notice that it's not a solid wash of green, even though this is a 4x4 matrix, and so there are numerous reverb returns in here. And that's because some of them overlap. Sometimes you get, like with this series of constants, and I see an immediate problem here. I do not know why these are showing as 0, other than maybe I have not identified this correctly. See, a bunch of these are 0. I think I have not updated all of my stop buttons to match. So I might need to do more debugging, but that's what I'm here to do. We're coding in Godot Engine. We are programming. We are solving problems. I'm looking at some of my notes to see whether they touch on this stuff, but it looks like not. Cat, excuse me. So that's going to be a significant change if it's actually going by this, because the chart is being drawn by something I'm pretty sure I have updated correctly. But then this data here, I can select all and show it, is being generated by a separate part of the program. And I don't think it's, or is it? So you see what's going on is we've got all of these different boxes in here, and they're setting different settings in the actual code. For instance, search for starts from here. So we're making a string of random numbers using this. We're doing a thing here where we are only allowing stuff that doesn't duplicate, and that's why it's weird that it's showing the way it is. Then we're going through here and taking all 36, and then we are spelling this stuff out here. We are taking the 4x4 and making that be associated with particular text edits in that little grid. And it's just a visual grid laid out by hand there. This is not a grid where anything understands that it's a two-dimensional grid. In fact, you can see that it's not even lined up correctly. We've got these guys here, which can all be scooched over by a couple of pixels, at which point they will be lined up better. But yeah, it's just physically laid out that way on the screen. And what's happening is something about this, like if I used this, it would fail to give me the results I need. So maybe we're going to start out with some bug fixing. Also, I do see the debugger has a whole bunch of objections. But that's not really a problem, is it? Narrowing conversion is typically something I will know is happening. I do that by default quite a lot, so. I may or may not have a picture of the matrices I'm using that will be of help. So give me a moment. I'm going to glance over here. I sure did. Here's the kind of stuff I'm dealing with. And the ways I've been working out how to try to get this to give me results I want. For instance, here's how I started out. It was originally a 5x5 matrix. And what I needed to do was sort out what the correct numbers were if it was a 6x6 matrix. You'll note I'm using pieces of paper to label some of the cables I have over there in the modular thing, which is now dedicated to electronic instruments that are to be triggered by a piezo trigger input thing. Yeah, if I can get this actually to be good and work, I may very well give people access to it, which will probably be troublesome because then people will simply want me to use their reverb options because they'll be like, I ran this for 5 hours and I set it just this particular way and I got this thing which is probably awesome, but I can't hear it because I can't compile a plugin, so you got to compile this for me. And that's never going to happen. But letting people play with this toy is only really helpful if they can compile one of my reverb plugins, particularly if I include like the reverb testbed plugins that I'm developing with. But yeah, I've got stuff like this where I worked out the sequence of numbers in the grid for reading the which ones are smaller numbers and which ones are larger numbers, because I can sort the numbers and then place them in this kind of order, hopefully making the across and down readings of the householder matrix, because that's the thing that I do, work out usefully. And all of that stuff lets me reuse the same batch of delay constants. And then I've got this. The 5x5 is A through Y, which corresponds to, no, that's a 4x4. No. The 5x5. I had these and I was associating them with A through Y. And then I switched over to having all of them by adding another plus 5 means it was 11. I added another 11 text boxes, and then it became this, which is A through ZK. And the reverb stuff that I'm fooling with currently is using the 36 by 30, the 6 by 6, sorry, batch of outputs. But if you remember, what I just did was I just ran this, and I ran a 4x4, and it's going to immediately show me some options. Unfortunately, what it is claiming is it says short A through short P. And it is claiming that H is 0 and K is 0, and N, O, and P are 0. And that is no bueno. Like if I plug that into my reverb, it's going to fall over and die. That's never going to work. So I got to figure out what's going on. Probably it is also worth checking to see if I have got the 5x5 updated correctly, because then I can compare the two. I know I have the 6x6 working. I do not know whether the 5x5 is... Ooh, no, the 5x5 is not updated either. Look at what's at the bottom there. I immediately see that the last ones in the option V, W, X, and Y are all showing 0. That is super unhelpful. And the only thing that's currently working is the 6x6. I bet the 3x3 is going to be even worse. Actually, I'm not sure. I don't know whether the 3x3 is going to be even worse, so time to try it. I know it'll display stuff. Yeah, F and H and I are zeros. So this is a weird combination. Also, this shows you literally what the density of the delays are. For instance, what we see here is for a 750-seater room, which is fairly large, a 3x3 matrix does not give you many effects returns. So it's kind of all spaced out. And I don't know whether this is literally showing me. One thing I could do is find out. Let me run that again. Seeing as the 3x3 is showing me some of that stuff. So early I is one of the ones that will be 0. So what I can do is find out whether that is the case for, let's see now, which one would it be? Oh, hang on. I have an even better idea. Bear with me. We're going to do something radical. Display window. Window can now be twice as tall as it was. Now if we go over to 2D, see that blue line? That is what's actually in the window. So now if we run it, we get to see what these are doing because they'll show on this screen. Let's give that a try. What does it do? We start it up and all of this stuff is sitting around here. For instance, this is the seat chasing thing, which will hopefully get you the target seats. And here's another test thing. Here's something else. A couple of labels that don't necessarily need to be there. Here's the stop buttons for all of these. And keep an eye on this grid. If we're doing a 3x3, like if we're doing a 6x6, all of these will be legitimate numbers. In fact, I'll demonstrate that now. In fact, I can even make it stop by shutting off this hidden control that says continue and then hitting the stop button, or it will simply stop when it comes to a new point. You can also see that it is, and I'll do that. Every time it generates and draws a new one, it hits that stop button and then it's drawing these words. In fact, it appears to be, no, that's still legit. It looked almost as if it had multiple copies, but I've told it not to. Instead, it's just showing the most recent one. And you see that A is 31 and B is 877 and so on and so forth. And this is the 6x6 matrix. I'm going to quit out because this is not really designed to switch around between stuff. I've designed it to run the program and leave it running overnight. And then once you've run the program, it's probably good. But here's the thing. If I hit 3x3, what does this matrix do? We're going to find out. I think a bunch of it might end up being blank. Oh, look at that. So we have an interesting development here. And I believe it may also be the case. See what that's doing? We have this little corner here that is not actually being read. My numbers for referring to some of these are not legitimate. So what's going to need to happen is the numbers these relate to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. And this combination of things originally referred to when it was a 5x5 matrix. But now this needs to be updated. So it doesn't get, this 53 doesn't get to be here, it needs to be here. And the 31 needs to be there. And I don't have it doing that successfully. But this is the chart that I need to be referring to in order to have it do that successfully. So let's see, 1, 2, 3, 4, 5. I've miscalculated somehow, that's for sure. I also am puzzled by, oh, I bet I know what's happening. 101 is supposed to be in the bottom corner. It's supposed to be here. I've never actually updated this, so I've got 1, 2, 3, and then I need to add another space in here, and then it goes 53, 79, 197, and then this 31 is supposed to be up in this corner, going 31, 59, 101, and that's how that's supposed to be counted. Let's take a moment and look at what the 4x4 matrix does and see whether it's got the same problem. Because I might have actually updated some of these, but no, I obviously did not. Interesting. And then I haven't run the 5x5 for a while either. Does that show exactly the same problem? It's all consistent, I'll give it that. No, 5x5 has something even weirder happening. That's interesting. So with 5x5, I clearly tried to fix it and failed. All the rest of them don't seem to have been touched at all. So let's see. And then, of course, if I run the 6x6, again, I'm trying to map these to this little setting, stuff that's labeled in here. And once I've successfully figured out and fixed this, then I can go and start fixing some of the other things, because there's a whole raft of things I gotta fix. Sometimes that's what the live stream is going and fixing a bunch of things. Contemplating just guzzling all the coffee in the world while doing this to make it a little more amusing. Maybe what I should do is, okay, so I know that if I am referring to the 5x5, unlike all the other ones, it is actually making some of these numbers be 0, and it is claiming those numbers are 0. I can see them in here, which also means that one of the outputs is 0 to 131, so that's completely wrong also. And yeah, all of this is deeply broken at the moment and needs fixing. So I'll be doing my level best. Let's take a moment, and here's where some of this goes. Like my 3x3, for instance, I pretty much see what went wrong. See how this goes text edit 1, 2, 3, 4, 5, and then 6, 7, 8 is being assigned something, and then 11, 12, 13 is being assigned something. But we're on a 6x6 matrix now. It's going 1, 2, 3, 4, 5, 6, and then going to the next column. So that needs fixing, but that's obvious. And this is being assigned stuff having to do with the order that I want them to come in. For instance, the number 1 is the smallest. We're getting them sorted. But this is incorporating all of the settings, and so this stuff is all straightforward. However, when we do this again over here, we're generating these. We are assigning what was in the matrix of little text windows. And then this is something interesting that may have to do, like here we are making a 5x5 matrix that should, I repeat, should be a 5x5 matrix confined within the space it needs to be. Trouble is, oh, will you look at that? Notice something about this? That is a 5x5 matrix like it's supposed to be, but it is reading 5, skipping 6, 7, 8, 9, 10, 11, skipping 12, 13, 14, 15, 16, etc. So that still looks right. It's not giving me the right results, but it looks right. And this might be where things went wrong. Ah, yes. Here's where things went wrong. We need to access all of the grid of things. We don't get to do this. So for starters, I may be able to get the 5x5 to work correctly simply by making this change. I'm going to have to update the number in there. You know, one of the things I've got, although it doesn't really work with GDScript, which this is, I've got JetBrains Writer, and it is capable of intuiting that you're copying and pasting something that fits with a pattern, such as 24, 24, 25, 25, 26, and over here 26. So 6, 7, 28, 29, 30, 31, 32, 34, 35, 36. You'll notice that it's not actually 30 because I have to correct these too. That should, although I'm not sure if I have, do I have brief delays at that size? Yes, I do. Okay, we're cool. Let's take a moment and see if that fixed the 5x5 just all by itself. I should have looked at this grid before, but I didn't. So 5x5, I'm going to say that's a big giant yes. We debugged it. That also implies that the other ones can be fixed in a similar fashion. I just have to pay attention to the pattern that it produces. But we'll notice that I now have a working 5x5. It's generating real algorithms as it's supposed to. And it's not generating zeros in the delay lines, meaning that I get to see what is a correct, like it's doing a better job of drawing this speckling of dots. And it's going to give me better reverbs on the output. So far, that seems to be working out pretty good. So yeah, what we see here in this corner is that it is now generating reverb returns. I think what I'm going to do is, firstly, let's go and see whether this is a problem for other stuff too, down to here. Yeah, see, I should just be taking everything here and reproducing it. God, excuse me. So where did I leave off? I think it was down here. And see, if most do printout, we have to make the text be this if it failed to produce a new one. So, and if I scroll down here, this is the full size one. In fact, I may be able to simply copy and paste all of this because it might be the same level of indentation. Indentation being how GDScript figures out its stuff. So let's see. I can copy that. I fixed 5. But here is where it's only replacing stuff for the bits it cares about, and that's not what I want. Instead, I want to, first order of business, we'll do this. Looks about right. We'll do the same thing here. See how it's putting back a value? And what I need to know here is, no, this is putting back all the values that you had, at which point I'll have a different behavior. It still won't be correct, but I can do this. And it should be the same for each of them. And this, and it needs to refer to that because it's reading some of these things. I'm not sure where it's getting delays be. Oh, I think it's actually, yeah, it's reading all of that stuff, and it is actually generating, but it's only generating a time delay. It's only generating time measurements. It's doing it by running the entire routine, but all it's doing is checking for time lengths. And that's because it wants to say whether it's a room, club, theater, hall, arena, or stadium. But then it does refer to all of these things. It's just referring to only relevant ones. Like here, hall 3. This is clearly wrong. 2, 3, 4, 5, 6, 7, and 8 and 9. It's this part of the text doesn't change. Also, I don't need to say collect. I don't remember what that meant, so I'm going to leave it off. Or, one of the things that I've been doing is I guess I'll just see what that does. I've been writing in 6s after the 6x6 one so that I can tell which ones they are. And maybe I want to skip that. I'm sorry if all this gets a little bit discombobulated and confusing. Note, however, that here is where I'm clearly reading in the wrong place. Let's jump back into this and see what happens. This grid is going to be doing something when I hit the 3x3, but I don't know what it is yet. other than I'm guessing it's wrong. And sure enough, what we've done is we've set it up so that it is reading correctly out of this. Don't mind the lawnmower. I was running my lawnmower early on, so I can't really complain about that. Don't blame anybody for trying to keep ahead of that stuff. It appears to be correctly reading from all the relevant spaces, including these 3 dots here, but rather than placing numbers in the correct places, it's placing numbers in the wrong places. And as a result, I think it's reading off of the stuff in the correct 3x3 matrix, but it's not able to get these values that are correctly been generated by the random assigning because they're being put in the wrong spot. And I did not spot it because I just coded a bunch of this stuff, added the additional 11 bins here, and then thought I had it set up correctly. So we'll quit out of there immediately, or as immediately as it lets me. And then here's where we run into problems. Yeah, if you think that the lawnmower is annoying, there's going to be worse this summer because there's folks who run around with dirt bikes. Now, you might think somebody who works in audio would not like neighbors constantly driving dirt bikes and little motorcycles around. But I have a drum kit, so I'm in no position to complain. So like they can run their dirt bikes, and then on the rare occasions when I'm playing drums, I can do that and record them, and I'm no worse than the other neighbors for doing that. And I'll pick appropriate times to do it, so it's basically all good. But that does mean that on the live streams, hopefully we will not end up having to like record delicate acoustic guitar pieces on a live stream when dirt bikes are going around or the lawnmower is going around. And let's see, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's reading the correct places, but it's not establishing the correct places, and here's why. I'm going to want to be referring to delays 1 through 9, which this is doing, but it's not doing it in the right place. So what's happening is I need to add an extra 1 each time. So it's going to work kind of like this. And then that doesn't count. Now it's going 1, 2, 3, 7, 8, 9, and then even further here, see what's that going to be then? Add 2 more. That should do that. I'm going to have to do this for each of these, but that's fine. And 3. And 1, and then these 2 over here. We're going to see whether this worked promptly. In fact, the second I got this done, I'm going to run this and see what I got. If this works, not only will these be in the corner here where they're belonging, but also, see, check it out. Also, what's being printed on the screen no longer has zeros in there. That is what it needed in order to be able to function. So what it's doing is it is correctly placing the numbers in the grid that I couldn't see before I changed the size of the screen. And then it's reading out of that same grid, and now I get legitimate results and can generate my little 3x3 matrix, should I want one. 3x3 matrices are very sparse sounding. You can do them. It's a fine way to do a relatively small number of echo returns that doesn't going to sound anything like a reverb. Probably a perfectly legitimate way to do certain flavors of early reflections. Like if you wanted to have a situation where it's like, this is a very convincing sense of early reflections in a larger space, so that all you've got is a few surfaces nearby and then it's just distant. A little tiny set of early reflections would work for that. Otherwise, the early reflections are rather densely packed. But this just worked, so let's go and do this again each time it's needed. Because I believe I've got everything. Like I'll do another test. The 4x4 should have, and does have, zeros everywhere except for the numbers I'm placing are in the wrong place. And then if I'm not mistaken, the 5x5 had the same problem. No? I stand corrected. 5x5 is completely fine. In fact, we can see it zipping along here. We can even see that it is running a similar pattern that I did for the 6x6. See, smallest one in this corner, then that corner, then 71, 79, 157, 179, 211, 233, 251, and then continues onwards as that goes. And I'm doing that to try to make it the... Also, interesting, look over here where the cursor is. I can make it larger by squiggling it. The bright little spots of green, these very bright bits, are where some of these reverbs, the delays, the combined delays, lined up, where the reverbs kind of hit most often. So what's going to happen with this particular type of display is the most densely packed reverbs, where everything's hitting on the same point, will be a bright green spot. If it was all just very densely packed bright green spot and there wasn't a good distribution of other delay returns, what you would get would be very dark, dim greens everywhere else. With just a couple, like if all of these delays were like 8 or 16 or 32, what you would get was a very intense few spots that just repeated, and then the rest of it would be dark. What we're getting is, since these are all prime numbers and they don't actually reinforce each other and they're distributed correctly, is more of a cloudy look where it's more evenness. I'm still remembering that there's going to be the 4x4 to do, and I will do that. But by contrast, if I run the 6x6, first of all, it's starting out at a much smaller reverb return based on it's kind of working its way up to what the correct size is meant to be. But with the 6x6 matrix, there's just way more reverb returns in there. So there are bright spots, but mostly it's a more even distribution of reverb returns. Whereas if you run the 4x4 matrix, unlike the 5x5, well, this needs to be fixed because a bunch of these are actually zeros. So you can tell that's wrong. This would be what it looked like if a bunch of those are being calculated as literal zeros, so they're repeating themselves, and so we have these bright spots and the rest of it is very dim. It should be a more speckled green look where you can literally see the green in it, but not as sparse as this, because this degree of sparseness means it's not functioning correctly. So off to fix the 4x4. It's going to be in search 4, not halt 4, because that's fine. I've already got the 5x5 fixed, and it's going to be up here. And in fact, literally this is the spot. So you see we have 1, 2, 3, 4 and a space, 1, 2, 3, 4 and a space, 1, 2, 3, 4 and a space. But that's no longer relevant to the distribution of those little text boxes. That's a 6x6 matrix now. So this needs to be fixed. And I am going to be keeping, I believe, the same arrangement of these. And I need to space these out quite differently. So maybe what I'll do is go by the one on the end. So we're going to set this up for errors, but it'll help. Here's how I'm doing this. I believe it needs to count 1 to 6 and then kind of go from there. So the thing we're trying to do here is reproduce what was there. 6, 3, 1. Then I can blank these guys out and follow the same pattern. Only 2 of them this time. I hate it when I have to talk like this. I can't believe anybody could possibly understand what I'm saying, and yet this is all I have to go on. Like, it might not make sense, but it's the only sense I have available to me right now. Then if I delete these, oh, I made a mistake. That needs to be a 2. It's good to not make those kinds of mistakes because they'll be very hard to find later. And then same deal with this. This needs to scooch down a little bit because all these guys have to move down 1, then 8, then 4. And then this one needs to be removed. And if I've done it correctly, I have a 4x4 matrix tucked into the top corner of all of those, at which point it'll work. So let's find out. This was the final issue. 4x4. And it appears to have moved them to the correct text boxes, which also means it's reading the correct text box. It was reading the correct text boxes the whole time, but then it was reading zeros. And weirdly, it still has that speckled look to it, which seems, and it seems all the more funny seeing as it's claiming that it's a 56-seat room and it wants to be 750. That's weird. What's that about? Methinks I have an issue there, but I can find out whether it's that big of an issue because I'm not really running large 4x4 matrices. So it wanted a 60-seat room, huh? We'll tell it to be a 60-seat room. Also note that when I change this one here changes because this is what the target is adjusting towards. It'll continue fooling with this number. In fact, we may even see it update as we go because it's trying to produce what will fit in that. And That's not doing a terribly good job of it. It's making it be smaller than it needs to be. But with the smaller matrix, we can see the dots on the screen a little easier. And the important thing is it's giving me a legitimate output that you could use as a reverb. Sizes might not be correct, but all the same. I wonder if I can update this on the fly. Well, that's not going to help. I have updated it on the fly. It now thinks it's going for 700 seats. It's updated this bit, but nothing about it is giving me some of my stuff that I'm adjusting things with is only on the 6x6 because that's what I was doing the work on. So you know what? I'm going to scooch the chat over to where I can get at some of my stuff. I'm going to call it good enough for now, although this probably could do with some updating. I'm going to quit out of there, and I'm going to fire up Stream Audio and play something while I go and make one more cup of coffee, seeing as it is not quite 1, and that's about as late as I'm willing to go for making cups of coffee. So we can do this, and I can even give you a visual. So I'll be right back with a cup of coffee, and then we're going to do more of this because we have fixed some of the problems. I am mid-coffee making. It's interesting hearing this from the other room in the way that the human playing is fighting against the machine time. This is before I had invented, for one thing, a pointy guitar, but it's also before I invented soft clock. And I hear the tension with not actually being able to entrain to the machine beat. This is the kind of stuff I'd like to learn how to do better. And in fact, I think I can do better going forward. But I think I'm pretty close to being able to finish making my coffee. We're going to do a big old Godot programming thing after this. So I'm back without having used up all of this 18-minute track. I keep getting stuck in things like wanting to remix stuff like this, but I would be much better advised to simply do new things along those lines if I want them. Like, there's so much human-played stuff over this that is restricted by the fact that I have this machine beat built in here. And if I had it going on the back of a soft clock, I might even have as strict of a beat, like the sharp attack on that kick, or these hats. But the thing is, the entrainment that this is producing is so hyped up it's impossible to follow. Although you can hear I'm trying. That snare drum there, that's human, I think. Unless it's not. That might be machine as well. Anywho, enough with this for now. We're going to get back to this. So I've just fixed the bug with it not being able to make its reverbs correctly. So what else is there? Well, one of the things I might want to look into how this is done. Kind of scoping this out, and I'm going to see whether I've got this total and since iterations in all of these or not. I do. So it's counting the same way each time. So where was I at before having fixed that bug? Because I had to go and fix that bug. Well, one thing I'll notice is that we've got these sliders going on here, but this one isn't using them. I'm kind of a mind of wanting it to be consistent across different ones. And I had an idea I wanted to implement, which I may very well be able to. 5 and 6 have these the same. So, and blue is actually going to be changed pretty aggressively. In fact, I'm feeling like literally the whole thing can be updated like this. That red slider, that is tracking the amount by which it applies my new metric for evaluating the things. And I was going to come up with yet another new metric and replace the one I have in blue. Green is, of course, the density of the returns. So let's make these all match across the different buttons. Oh, hi. Why do we not have a green amount? Well, we do now. And so now that matches. I don't know what was the deal with the green amount gets applied here. And the 6x6 is Delays total. So earlier on I had a system where I was going for a chamber or what I called unique. The difference between those two things was the chamber was delays total times delay total times green amount. Unique was delays total times delays total times delays total times green amount. And this happens in two places, so it's got to be like this. One thing I'm doing afterwards, I'm tracking the peak green, and that's something I'm going to need to include. So let's make sure that's in everywhere. Where are we calculating this? Here it is. I do have it in there. I have included it with that one, but what about here? I have it in there. I am in fact tracking it. And what about the 3? Not in this one. Okay, so where does that show up? It shows up after displays fill. So we'll sneak that in there. It is kept track of here. Sometimes I need to update the thing. And it's done twice. And then at the end, we do most divided by square root peak green. So everything gets scaled kind of to work together. Here is, and was I doing it before or after? I was doing it after adding brightness. Brightness is something that scales based on what we're doing. This has to be scooched over a little bit, but X is in fact the thing that we want to use. It goes in after brightness, and it scooches over 1 because Godot is sensitive to spacing. The indentation has huge relevance to Godot. And then, like I said, at the end, what we do is we do most divided by square root peak green. Oh, mistake, but not big mistake. I just have to put this back. That aligns with these because it is back out of the for loop after all the for loop has been done. So now when I run this, oh, I see something else. I see something else. Remember how I said that this one's not using, so the way this works, if I make this little change, it will probably make all of these sparser. There's a significance to what it's doing to the reverb if I make this little change, or if I change the other ones back. So, delays times green amount. Most plus equals that. Here, it's saying delays times green amount. But this one doesn't have a green amount, nor does this one. So first order of business, we need to start including this because this is how we adjust the total effect of this particular parameter on things. So we've already got it in these places, but these ones, it's been left out. So there's one. And there's another. And here's one. And here's another. It's not going to do anything right now. But let's quickly run this a couple of times, and I'm going to show you something. So this has a smoother, although it's starting out with a very inadequate setting and kind of chasing its way up to the ideal place. There's an onward period. Yeah, that's right. See how this is a solid green? I'm going to be doing a similar thing with blue later. It's a solid green. However, when we run the 5x5, oh look, it's more speckly. It's not as solid of a green, and I'll tell you why. It's because this one is taking each of its little values and it's counting the high values for more. So we've got these bright little spots, but most of it is much dimmer. If I go here and I make it look more like the previous one did, sorry for the bong, I bonked the microphone by accident, and then I run it again. Guess what? It's not quite as speckled anymore, because it is weighting things differently relative to what counts as a good score and what does not. And it's drawing the picture on the screen relative to what counts as a good score and what does not. And since I fixed the little grid of boxes in there, now it's able to actually make relevant assumptions. And that should be the case even for the 4x4 or indeed the 3x3 now that I've got that one up and running as well. In fact, on the 3x3, it's even less relevant to do this because the 3x3 almost cannot... Oh, what did you just do? How about a undo and a quick little redo? And then go after this one more accurately. And then while I'm at it, let's do all of them together. So this was previous settings on a previous application. I had a separate setting for these two adjustments. The chamber was the this times itself, and green amount is of course the amount of total that you can have. I had an additional parameter in there, except for it was a factor of how it did this analysis, where you could have most plus equals how big those. So most plus equals what this is becoming. The green dots, the amount in which it is loading stuff up with reverb returns at a particular place. For a 6x6, those places are densely packed with a bunch of reverb returns. For a 3x3, it's not very packed at all. If you have it as delays x times delays x, it's going to weight the ones that have repeated on themselves more and profoundly make most become a larger number as the delays get stacked more highly upon each other. If it's just delays times delays times delays, then it's like the power of 3 over how highly they're stacked. So anytime you get a end result, see the delays x plus brightness, every time it settles on one of these, it makes it become a little bit larger. And each time it becomes a little bit larger, it starts counting on most, which is their scorecard, higher and higher. So if they're all landing in the same place, most becomes a extremely large number, and it's being evaluated as to whether to keep or discard it based on whether the number is as low as possible. So having them stack up like this means that isolated little peaks that are poking out louder than they're supposed to are extremely penalized. But another thing that I was doing earlier was making it so that you would have delays that were early in the reverb tail weighted differently. So basically, if I was to go most plus equals delays x times position in the reverb tail, and what would that be? That would be something along the lines of, other factor also x, but for instance, what we've got here is delays t. Basically, we're counting along all of these. And so this is the size of the whole reverb tail. We've set it up so that array size is a little bit beyond the biggest stack of x we can possibly get. So then see how we're doing spacings between the active taps of the first delay. And we're having to step by twos because it's prime numbers, and so you can never have one of them landing in one. And zero run gets added, and then we have this thing called spacings, and we add brightness to that. And then we're also kind of exaggerating or weighting it. We're doing this thing times equals square root 0 run times 0.25. Square root will tend to make things converge on 0. So that's another weighting factor. That is editing the red dots are spacings between reverb. I'll show you rather quickly. I say spacings between. Well, let's do a 3x3. That's got lots of spacings between. And so here we have a bunch of reverb returns, and this little dot in red is a repeated echo return. It has these in common. And then the little fainter red dot is another spacing between these echoes. And that's basically how that works. It's not actually showing up very well in the 3x3. I'm going to run something else. For instance, 4x4. I've been adjusting some of these things as I go. That shows up much better. So what we're seeing is the C. I'm going to be working on these blue dots. That measures something else, which I'm going to be adjusting. I think I can determine whether a reverb return is going to be brighter or darker based on amplitude of reverb returns. But this little splotch over here is in two different colors. One of them is a sort of mustard color, and the other one is shades of brightness of red. And that determines how often there's a spacing between reverb returns that is blank. So if there's an echo return and then there's like 12 samples in another echo return, 12 pixels over, there will be something over here because it'll have counted those. And as you can see on a 4x4, there's actually a goodly number of spacings because it's not all that dense with echo returns, to the point where I'm not finding 4x4 matrices useful for reverbs. The 4x4s are in my clear coat, cream coat, etc. Those ones are all 4x4s with many different options for what the matrix is going to be. And they're all basically like this, different sizes of room. This is wildly off as far as what you're asking for, 750, and what it's giving you, which is 82. But some of that might have to do with something I was fixing in the 6x6, so that might also be worth working on. Then when I run it again, and I go by a 6x6 at the same size, it's leaving space for a lot more, but you'll notice that like right up in the top here, it's always going to have the same across for the spacings. Like 10 pixels equals 10 pixels, whether it's a tiny one or a large one. It just wraps more times, which is why the dots are smaller, they're fuzzier. And what I'm doing here with the score is what I'm going to be incorporating for some of the other ones. It's doing a thing where there are two changes that are going to have to go in today before I get even more creative with this stuff. Possibly before I do the thing with the blue dots, which you can't even see on this one, so there's that. With this implementation, the 6x6 implementation, it's setting the score based on what the output of this that made the picture here. It's taking that and printing it to score, and then it needs to do a better one in order to replace what we see there. But there's a catch. And here's the catch. If you told it to do what equates to a really good sounding small room, like I was experimenting with some stuff that sounded pretty amazing for like Led Zeppelin Where the Levee Breaks drums, or the little small stone room that you can use to record in, meaning that you could put anything into there and it would sound a little bit like that gated Phil Collins 80s stuff, because it would be the stone room sound. I would run 15 copies of this program overnight, and what they would do is hit upon one result almost instantly and then never change from that again. It wouldn't matter how long I ran it, it wasn't coming up with anything better. And that's against the principle of how this is supposed to go. So what I ended up doing was modifying this score setting. And what it does is it's checking how far it's departed from the desired size of the seats. And again, over here is, I'm not being able to click on this, it's fine. This is how many seats it thinks it has, but this is the end result that it gets. And what it was doing, if you set it to a very small number of seats and did the 6x6, what it was doing was stacking reverb returns on top of each other so densely that it skied the score to impossibly tall heights. See, and now we're hitting some new ones. So what I did to fix that is it doesn't actually write down what the score it got, because sometimes that was a much larger room than we were trying to get. And the thing about stacking up reverb returns on top of each other is that if you pick a really small room in a 6x6 matrix, they stack on top of each other so high that the score is enormous. And then if you randomly hit a much larger room by mistake, much larger than you're trying to get, that ends up with a weirdly low score because it's a larger room. It's longer delays. They don't stack on top of each other at much. And then when it's trying to find its way to what you told it to do, which is a 750-seat arena or whatever, it would be comparing everything that it tried to accomplish against this impossible goal of like the 5,000-seat theater, which you didn't actually want it to do, and everything would fail. And I spent a bunch of time generating reverbs where it would be hitting these results, and they were fine. 6x6 reverbs sound amazing. But it wasn't able to do this iterative process where I can run millions upon millions of examples and gradually find its way to the best ones. Calbless? No, that's a very interesting question you've asked. The matrix is read in two directions. So we'll start with L. And I know you're seeing this because it's being drawn on the screen. I'll leave it here, grinding away and trying to do its thing. Your left channel, for instance, it's going to be like here's, it's groping after some more. We'll let it settle down a little bit so that I can talk about it coherently. This is relevant to what I'm trying to do with it, but it might be a while before it settles down to the point where I won't be able to give you the numbers that it shows. So your left channel starts with first line is 7, 811, 631, 523, just changed, 31 on the end. Then it's this top line, but it's 257. See, it just changed again. Then it's this top line, but 457. Each of these is going to be a unique reverb time. The way the householder matrix works, it can calculate it out that way. So you wind up with every possible variation through this bank of reverbs. So what happens with the right channel is we start at the top and go down. So we start with this 37 and then 257, then 457, 641, 859, 181. And then we swap out 1021 for the 181 or whatever. It's left is going right to left. I'm sorry, left to right, sorry. And then right is going top to bottom. Meaning that it's all going to be the same actual reverb constants, but they're going to be distributed differently. If I've got it worked out correctly. I'm pretty sure that's how that works. And that gives slightly different. It'd be pretty funny if it didn't end up doing that, but it gives slightly different interpretations of mono signals that way. And everything ends up going through every delay in the long run. Yeah, because first iteration through, it would actually... Don't mind me, I'm puzzling this out. I might be goozling myself a little bit by having done this fancy horizontal and vertical thing, and may or may not actually end up with different results. It's possible that reading it right to left and then top to bottom doesn't actually give you any differences, which would be an amusing twist. Suppose I could do that by having a look at the 3x3. So yeah, the question becomes, if you're doing a 3x3 matrix, left to right, then also top to bottom for each channel, if you're doing that, does that ever give you different results on each respective channel? Like, do you have to go through it multiple cycles? And that's probably something that I could sort out. It's just a question of, like, do our permutations wind up? Because here's the thing. We've got these matrices, meaning that on left to right, you can never have a output in which the numbers 43 and 89 are combined together. Left to right can only do each of these things alternately with 43, 89, or 109. And no combination of things will ever give you a reverb path in which the reverb path first does a 43 delay and then an 89 delay and then anything else. The stuff in the column cannot be combined together, no matter how many variations there are. Like each of these variations is going to end up with either 43, 89, or 109 as the final delay. And then all the combinations of those things make up the matrix. However, reading it from top to bottom, and I mean, technically I know that this works because I habitually, hey Grants, I habitually generate the end results of these, and the left and right channels can be wildly different. So yeah, I have an existence proof that it is actually different. It's just using all of the same numbers in the long run. Meaning that you don't have to have an entirely separate bank of numbers. And that's why I evaluate it in each direction. So yeah, so there's that. Now let's see where I left off. Okay, we were doing that. An interesting side note here is, as we get to this section, the zero run section, sometimes it says disk delays T, and sometimes it has to say T plus 1. Although it seems pretty well behaved so far. Actually, wouldn't it be? I know what I'm doing. So what's changing here is, depending upon how these things are worked out, the bank of delays in disk delays needs to be iterated over. And I need to go through and get all of the legitimate results. And since they are all primes, none of the even numbers will count. So it takes up a little extra space. What that means is I have to start this iteration at a different number. Like for int in range 3, array size -1, 2, or int in range 2, array size -2, or int in range 3, int in range 2. Depending upon how it works out, I need to use different numbers, or that part of the measurement will simply blank out entirely. Like it won't register if I'm not counting them correctly. And I'll tell you why that is. It's because if your delays are only prime numbers, but you're iterating through them in a 3x3 or a 4x4 or a 5x5 or a 6x6 matrix, well, then the end results are going to be in different spacings as well. So maybe they will be in even numbers, maybe they will be in odd numbers. It depends upon how big the overall matrix is, because 3 prime numbers that themselves are always only odd numbers. If you have an even number of those prime numbers, an even number of odd numbers added together, it will end up on only the even spacings. So that's how this works. The T in range, whatever, is going to relate to the size of the matrix. And so my little thing up here where I'm iterating through every possible option, every possible variation, that is going to produce a data set that is either filled with odd numbers or filled with even numbers. And those are the data that I'm running from. I want to skip ahead to something I was talking about that I needed to do. Before getting to this stuff that's more fun. We've got up here this thing that says do printout. And it's going to be here as well. Prev score 2. That's the part where it's writing out a score. And that's the important thing, which makes it so that it can try to continue to find better options. The ultimate goal is to have a generator of delay matrices that sound freaking amazing. And I don't quite know how to make that happen, so I'm making the machine do it for me. It's about finding what the evaluation principles are. Like, would the evaluation principles be all of those delay lines are the same number? Surely not. That wouldn't sound like a reverb at all. It would sound like one single echo. Would it be all of the delay times are evenly spaced? Probably not. What kind of distribution do you want? And the end result is you run something like, for instance, your traditional 4x4 matrix, and you wind up with a distribution that looks kind of like this, where you got this speckling of end results. And that's where stuff like overlapped. And the spacings between the end results are this little block up at the top here. Oh, nope, absolutely. 100% I want to crack the code of why reverb sounds like reverb. And I'm getting to some useful results. Like the stuff that I've gotten up to so far. I have the green measurement, I have the red measurement, I have the blue measurement, which probably needs updating. Green measurement is how densely stacked these reverb returns are when they're just repeating themselves. Like when I've got a matrix and the matrix is giving me 30,000 delay returns, how are they distributed in time? Oh, I don't use all-pass filters. All-pass filters are how you make this reverb be smooth sounding, but at a cost. I don't think they sound very convincing. They sound like my MV plugin is all all-pass filters. I'm trying to do just only delays and have that sound amazing and as smooth as if you were using all-pass filters, but without using them. Which is a challenge. And some of the stuff that I've done, like the 5x5 matrices that became K Cathedral 3, K Cathedral 2 and 3, started using more in the ways of sneaking some all-pass filters in and the smallest delays. And all-pass filters are not any heavier than comb filters, really. They're not all that much heavier. There's a little more math going on. It's not all that much. But yeah, you can make reverbs that are all-pass filters, and they sound like those Bloom reverbs out of the MIDI-verb 2. They sound like My Bloody Valentine or whatever. It's a neat sound. I've got a plugin that makes that sound. In fact, I've got a one of my... Let's see what it would be. Clear Coat? No. Cloud Coat. Try out Cloud Coat if you want to play with all-pass filters. It is the same delay lines as Clear Coat, except for they're all turned into all-pass filters. There you go. There you go. It's a 4x4 matrix, so it's a smaller matrix, but If you want to play with all pass filters, that's the one to use. So where were we at? Here we go. So here's where it would originally say get parent, get node, prev score 2 text equals seats. That's the correct answer, is seats. What I've done, and what I'm going to be doing with all of these going forwards, is this line of code here. So what this says is prev score equals, actually no, most. Prev score to text would be string most, but in cloud code. But now it says this. It says most times 1 plus maximum of target seats text to float, or no, seats minus target seats text to float, comma 0, divided by iterations. So what does this do? I was developing this all morning, because this was my way of getting past that 6x6 matrix stalling out at small sizes. And I got it to where it was able to run overnight. And I'll show you. These are all going to sound fairly similar, but that's kind of the point. Like, I'm trying to go beyond the beyond into new areas beyond what I was able to do before. And weirdly, I only see a couple of answers here, and I only see 2 of these, and that's funny because I thought I had more. No, I think I generated 5 and only 2 passed muster upon measuring. So what I was doing before sounded like this, because it's a 6x6 matrix. And they all basically sound good. And what I did was I went through and made it so that it could continue to try to find better and better combinations of delay returns, at which point I would be able to get, rather than a pretty direct sound and many variations on that, I got into this kind of zone. So the difference between those things, and I can even what's going on there is doctoring it in this way so that rather than getting stuck on largest possible room that fits the conditions and just staying there. And so all of this stuff that I'm looking at is more or less just a very rough estimate. It's this many first choices for all of this stuff. And I'm wanting to make it go, I'm wanting to make it pick through more options and try harder to get a result. So that rather than having it sounding like that, it should sound more like this. Weirdly, it's not sustaining as long, but the texture of particularly the lower mid-range feels to me more like an actual room. Here's a 195 compared to a 196, or 195 compared to a 196. Both of them are fairly similar. Both of them have the blue dot, meaning they're fairly dense. Both of them have the green dot, meaning that they are darker. So I should be able to go from one like this to one like this. And that one is actually a little bit more sustaining, but also you'll notice that in the measurements size, the recent one is showing up with a slightly larger size. It's 25.4 megabytes versus 25.1. These are FLACs, so it's lossless. And that's one of the things that I think I'm going for. Again, here's another one where 198 and 200. The 198 was 25.1. There are a bunch of bad sounding ones that are even lower, like 24 megs or whatever. And then the one that's almost exactly the same size is 25.3. And they're all hanging around being pretty consistent in size. But that's a good sign, because it is my opinion that if you're doing FLAC encoding with the same encoding, the same level of compression, then the more incompressible one will be the correct answer. Because acoustic reverb shouldn't be easy to compress. It shouldn't have like consistent patterns in the data. It should be more difficult to compress, and that's what I'm seeing. I haven't even looked at that, but that is consistent. Even to the point where a previous one that actually worked out good, 196 here, is 25.1, and then 195, which is a smaller number. Generally, as the decay goes longer, then the incompressibility gets higher because it's continuing longer. But today's one is actually more incompressible than any of the previous ones I've done, and that I consider to be a good sign. Worth checking out going forwards. Like here's 25 point, well, I can't actually compare it that easily. But yeah, this is what I'm shooting for at all these different sizes. Here are some much larger sizes. One of the things that happens with these is if it's the much larger size, you can plainly hear where the densities of echo returns show up. Listen closely to what this one does, or this one for instance. That's fairly consistent, but then this one had a echo equality. There's the echo equality, and that's fluctuations in the density. I can measure that stuff. So part of what I do in checking these things out is work out, for instance, whether, for instance, if one of these delay returns, I should be able to measure whether it does that. I can show it more easily with a really big one. How about one of these ones that doesn't actually do all that well? Like this ought to be a echoey sound where it doesn't sound like a continuous wash, but instead sounds like slapbacks. Or not. Yeah, that's pretty consistent too. We'll go a little smaller. Also pretty smooth. All of the 6x6s sound awesome. I can't show you the thing I was talking about, but that's not important because the fact that they are all awesome is good. One of the reasons I measure them with these colored dots is because I can set up measurements where I'll do an analysis of them and come up with numbers, and then I can check the numbers to optimize for things that my ear will just fatigue if I try to literally listen to all of these and pick out which is best. And that's how I come up with like this OGBP means it's sort of all of the above. It's loudness, it's darkness, it's solidness, and it's clearness. So a little bit of that flutter echo in there though. Let me stop fussing with this for a moment. And the thing I was talking about was this bit here, and also Gib had mentioned something which I can answer. But what I'm looking at here is how it successfully doesn't get stuck in a rut. Is the score, but the score can be written down as higher than it actually is. In particular, if the seat size is larger than it's supposed to be, then it will write down the score as higher than it actually was. And divided by iterations means that the amount of effect that has goes down and down the longer you run. And I made it so that it was not going to get stuck in larger reverb returns by simply forcing it to ignore that stuff and zero in on the correct amount, meaning it could never actually get stuck on a very large reverb size and then only keep that one and ignore all of the possible variations, because it would write down that score as artificially high because it was an early result that was a really large room size compared to what was being asked for. Hence, seats minus target seats. And then there's a max in there, meaning that if it's, rather than just absolute value of that minus that, meaning if it's anything different from the desired number of seats, it's penalized. Instead, it's only if it's much larger, because that working with the 6x6s and 5x5s in small room sizes, that's where it runs into problems. So quick bounce over to lossless means the sound file is raw. Nothing off the sound is being changed or altered like with an MP3. Correct. FLAC is the same as WAV. A FLAC file and a WAV file will null. You can save a WAV as FLAC, load it back up. It will null if you flip the phase. That's the whole point of a FLAC. There's also an Apple version called ALAC, and that's the whole concept, meaning it never gets compressed as much as MP3s can, but you don't lose anything ever. Gulping down more coffee before it's too late in the afternoon. It is heading towards past 2, but this is proving to be a useful day for this. So here we are with this line, which I'm going to copy over to every other place that it belongs. Assuming it's not already there. So it shows up right before var venue. And I've already got it applied to the 5x5. Yes? Yes. And I probably don't have it applied to the 4x4. I stand corrected. I do have it applied to the 4x4. What about the 3x3? That would explain why it keeps turning through these things. Oh, yeah, sure enough. So yeah, for all of these, it's generating these scores that are scored as most. Everything always, as I measure all these things, it all gets added to this number. And it's added based on the settings of those sliders, which I'm probably going to change. One of the things that I was doing in an earlier version of this program was setting it so that you could use different evaluation factors, like more of this, all of the delays added together, or more of the spacing between the delays. And I evaluated what they sounded like, and I've got examples of all of those things in select verbs. Meaning you could listen to what it sounds like if you only care about spacing or if you only care about loudness. There was an earlier version of the program where you could pick between things like only care about the loudness of the echo returns multiplied by itself twice or multiplied by itself 3 times, and that would give you different sounds. And I've just switched some of that back from the 3 times to the 2 times across the board. But it's all options of how to weight this stuff. What you do to make one set of random delays be considered better or worse than other sets of random delays. So there is a thing that needs a little more work. Here where it says billion equals int get parent get node total iterations text int, that is there because if I run it for too long and it goes beyond about 16 million trials, it crashes. And that happened to me a bunch. These days with the 6x6s, it can't even do that running overnight. It can't get that many. But with the 5x5s and etc., and the faster I make it run, I could run through so many of them that the program would crash, and then I wouldn't be able to get the output because you couldn't select anything in the screen if it's locked up. It would just be stuck. And I can screen capture and do OCR off of the screen capture, even just in basic macOS is able to recognize whether you're trying to capture text off of an image. But it did that erroneously. It would make mistakes. So there is an additional variable that I should do. And that would be million. Because when I ran it overnight, what was happening with this new setup was some of them, including the ones that I just showed you that were pretty good sounding, had gone a really long time without being able to find a better option. They had gone through many, many iterations. And then other ones would go for a long ways and then start taking advantage of the way it's setting the high score to be technically larger than it really is. So you'd have like a 30,000 score, and then it would hit a 32,000 score, and then it would hit a 40,000 score, and then a 90,000 score, and next thing you know, it's groping around, constantly updating, and constantly trying new stuff. It had a really good result and threw it away. So the way I can make this stop is by tracking the other control. This is total iterations. This gets updated going up 1 every time it tries a new option. This is the one that gets zeroed back out again when we've achieved one and gone on from there. So what I'm talking about is I would run this. This one would keep going up and up and up and up and up and up indefinitely. And this one would be starting over every few seconds while it was getting going. And in fact, I can even show you it doing that. We can run the thing. We'll do a 4x4 just because why not? And off we go. This is the number of total iterations. And this is the ones where it's decided that this is the best that it's got, and it's continuing to go on from there. Now, what was happening the very first time around when I was not able to ever get it to try a different one, it stuck with its first one and then that was it. And I do wonder whether that's behaving itself properly or whether it's done the same problem as before. In fact, I know what to do if it was. There's something earlier in the code, right up at the top here, where maybe it needs to be consistent. I'm just trying to find it now. Maybe it's even farther up. Total since 0. So I'm trying to find where I did a specific thing that's different for each of these. And this one, it's the highest. And then the other ones, not there. Yeah, trust me, I know what I'm looking for. I don't know exactly what it is, but I know what I'm looking for and where it lives. So pref score 2, most times 1 plus max seats minus get parent target seats. Text to float divided by iterations. Okay, so here's a legit question. Maybe I edited it back out again? I had something in here somewhere. And maybe I did. Yeah, no, I think I did. I think I just edited it back out again. Well, let's see whether it does anything differently if we make a really tiny number of seats. 4x4 matrix, 20 seats. Yep, see, that's what I was talking about. I think it's a matter of it's going to try to do that as stuff overlaps more. And the problem, which might be worth me checking out and doing something about, is that, yeah, see, and starting over, is that it's meant to do this as it starts up. It's meant to have a harder time sorting out what it wants to do, and the stuff that doesn't fit gets more easily discarded because it's based on departures from the room size. So maybe what I need to do is increase the strictness of it by making it absolute value rather than max, specifically for these larger ones, because what it's meant to do, it's looking for a optimal score, but there's a tendency for it to hit values that for arbitrary reasons are not really a high score. It just happens to be scoring high in another metric, like little tiny rooms where the delay lines are overlapping each other too much, and so arbitrarily, if you're doing a much larger room, it's automatically a better score without necessarily sounding any better. It's just larger. It's just not overlapping as much. So what I could do is force it much more strictly to penalize any departures from the ideal number of seats. I've already got a separate thing going in there, which is trying to converge on what the optimal number of seats would be. That's what this updating number is doing. if the result that it produces is larger than the target, or the delay lines all added together are larger than that target, it updates what that number is and runs it again. So you see it's bouncing around a little over 300 to a little less than 300. And it's doing that based on where the delay lines added up landed relative to the target size. And the seat number is basically milliseconds. It's the size, it's the length of these. It's kind of an estimate, but I kind of guesstimated it as to how big a room sounds to me. And that's all that means. That the seat arrangement is strictly what sizes does this generate. So yeah, it might be worth me forcing things like this. See, most times 1 plus whatever this is divided by iterations. Iterations is going to increase into the millions. So it ends up being a smaller difference. Max means only variations of this that are too high and thus more spaced out. So in theory, they get a bonus in these really compressed sizes. But if I make it be abs, and then take away the comma and the 0, now it's going to penalize any departure in either direction from the seat size in a way that becomes smaller and smaller as iterations gets larger and larger. And we'll see what that does. Because again, this was originally because it misbehaved when it was a very large room size relative to a very small target. But changing it this way means that it's now penalizing any departure from the target, and that penalty becomes smaller and smaller the longer we run. And that's how you do this kind of thing. You figure out what's going to make it do what you want. And I am going to... isn't Block Party already a compressor? I'm not sure why you'd think Block Party wasn't already a compressor. It's already one of my plugins. It's already a compressor I made. Let's run this real quick. Now it is penalizing departures in either direction from the ultimate target. So I can... 190 was becoming a problem when I was running it on the 6x6s. I'll run it in the 4x4s or maybe even the 3x3. No, I'll call it the 4x4s. I'm going to set this to run, and I'm going to scamper off and make a really quick pit stop and rinse out my empty coffee cup, and I'll be right back. And we'll move on. There we go. Alrighty, I'm back. Block party is not properly a limiter because I don't have any proper limiters. Not quite. So yeah, what's happening here as we run this is it's generating the correct results of this stuff. And as you can see, it's constantly coming up with different options. If it's able to come up with a result that looks like 190 seats, and it's bouncing around madly, then score that gets written is going to be written artificially as, we'll put it this way, when they are wildly incorrect. There we go. So that was a 190, it just wasn't a very good one. Score is the result of each of these things, but with an additional added boost from how far away the seat recording is. And we can kind of run it like that. I'm pretty sure the 170 down there is the number of iterations that I'm doing with each one. It bounces around based on how quickly it can do those. And as this goes along, like the distance between the target and the number of seats it generates is being added to score, and low score is best. So what we're doing currently is bouncing around a lot, having great difficulty settling on anything, because the randomness in the 4x4s is generating widely varying like verb sizes. Also, it's weird that I guess it's drawing the zeros when it's able to move on a little bit. And then it's drawing the blanks when it's not able to move on, and it's just constantly doing new attempts from scratch. But as it keeps going, the amount of additional penalty, see, there we go. For a moment there, it had a score of 11,000. And if it had hit that first off, it might have had a great deal of difficulty making anything worthwhile out of it, because it wouldn't have tried any other options. Now it's currently trying all of the options in the entire universe. And every time it's taking the difference between the target seats up top and the end result seats and dividing it by the iterations here and writing that down as the score, which is why all of these scores are coming out as, while X restricted, I would just start trying them. You're probably looking for like 2 tape 8 or something. Now, what would normally happen is we would get beyond this stage, but it's taking a long time settling down, and that's fine. I am curious, however, as to whether it's going to tend to do that on other options. For instance, I can do my 6x6. See where it says 20 here? I was generating more of these with the 4x4 because that'll run really fast. My problem with the giant matrices was that I got too much overlap, and so it favored stuff that was too large. So what I could do is pick an arbitrarily large. This is going to take a while, but then I can see how it gets about doing its thing here. And one thing we can see from that is that as we select this very large seated arena, it's doing an okay job of finding its way, but it's taking a while to gear in because that difference between the size of the seats and the end results is causing the score to be written down as higher than it would be. If it wasn't doing that, what we'd be seeing is it would hit upon a low score, and then it would really have to outperform that score in order to be able to move into a next one. Since we're not doing that, it's trying all of the various options, and that thing that's bouncing around and going like 85, 100, 94, that's the number of tries it's doing between updates. Because there's a loop that it runs where it tries to fit. The 4x4 was doing like 170 plus. 6x6 is bigger, it's not able to do as many. And so what I'll be doing is setting something up like this and leaving it to run, and it'll start out with these massive departures. I wonder whether I can update this on the fly. Apparently not. Oh boy, okay. It became upset. I'm asking it too much now. So, let's see if I can delete that 6. There we go. So now I've updated that again, and we're closer to the realm where it's able to actually do. So now we're closer to what the seat number actually is. And so my score should end up hitting lower settings because the end result here is closer to the 4,000 I'm requesting. It's bouncing around in the vicinity of it. What I'm looking to see, and I may or may not actually get to see that, is it settling the heck down, which it's not doing a very good job of doing, and starting to hit scores where rather than just constantly resetting all the time, it starts going, okay, this is a good one. Let's see if we can top that. At which point this will increment, but this will stop being 0. And we're not there right now, clearly. So all of these might end up sounding quite interesting. It's just that they're not exactly what I had in mind. And in fact, I could probably pick a little small size. Ooh. Well, that actually might be something that hangs the computer. See, I'm moving this around. I'm going to get the beach ball to death. See, there we go. It may never actually be able to generate an answer for me. Oh, no, it did. It's just going to take forever, and it's only able to do 26 of these between updates, and even then, that's kind of sketchy. But this amount of overlap means very high density in a 6x6 matrix packed into that small of a reverb return. It's a very dense end result. Okay, so that's cool. What I was hoping is I would start getting updates where this other one updated, but we're not there yet. I'm going to try to quit the program, and it's going to fight me because it's trying to do too much. Although I don't have to. Tell you what, I'll switch back to Godot and hit stop. See, I'm running it in a debugger, so I'm able to just arbitrarily stop it if I want, whether it's hung up or not. So here's where I need to add something that I'll need for running this overnight. And it's going to be this. Don't throw that in my face. Jeez. How is that supposed to be helpful? You throw an autocomplete up into my face, and it's not even what I was looking to do, and then look at it. So I need to add that in, looks to be 7 more places, and I'll tell you why. The fire redraw thing, where either it can continue running the program or it can simply stop, has to do with both this and the halt program. This comment about 63 instances, not going to be useful. So first, let's go through and update it everywhere I need it. It's being a little bit of a pain in the butt making me horizontally scroll, but whatever. Here we are. So this doesn't run constantly, but it runs when I'm redrawing everything. And this all has to do with these other buttons. Now there's going to be a variability in these halts as well. See? So we're first going to go through, it's going to be exactly the same line of code. I might have to horizontally scroll some of this stuff, because it has to be exactly that line of code. And you have to have both halves of this bail out in order to successfully make it stop. So see where halt 6, it says if fire redraw or billion, do this, otherwise do that. In this case, it says if generating and billion is less than this, then do that. This is all the mechanism by which it does its thing. And again, that's a billion less than or a billion larger than. So the logic of this is fairly simple. Continue to have additional logic statements, but there now has to be a million related logic statement. Namely, another or larger than a million. So if I do this with all of these different things and then set it to running overnight, it'll grind its way through, constantly trying to update itself based on whether it's trying a new thing or whether it is settling on a high score that's hanging in there pretty good. The trouble with that is that the ability to, cheat and give up on a high score by picking progressively worse scores because there's a wiggle room involved in there now. It's able to weasel out of the high score, in other words. It's able to hit a high score, go like a million iterations without having hit anything better, and then still wind up degenerating to where it's like, oh, that's not that much worse, but I'll try it. Oh, that's not much worse, but I'll try it. Oh, that's not much worse. And then end up back in the doldrums of trying really bad options. This is the bailout where It bails out, yes, if it is 16 million, because if it wasn't bailing out over that, then it would kind of just crash. But if the since iterations, which also increments when it's got a really good score, if that goes up to not 16 million, but just 1 million, it'll stop. It'll be like, nope, I'm satisfied, good enough. Because if it didn't, it would be running the risk. And I watched this morning as I came up on 12 instances of this program. And they were all doing like, for the thing that I was running, it was like, okay, good is low 80,000. So it was doing a bunch that were low 80,000 or mid 80,000, and one was all the way like 79,000. I was like, oh, cool, that's really good. I'm going to go make some coffee. I went away, I came back, and a bunch of them were hovering around 190 and so on, just updating themselves like mad, even though it had been running all night. Because it still had that ability to not get so strict that it couldn't do a series of progressively worse choices and then end up screwing itself over. And so that's what this new update is about. And I ended up keeping those ones that you saw because those were the ones that were too high of a score to screw itself up. Like I got to keep the 70,000 one. It's one of those ones that you heard. There were a bunch of other ones that might have sounded perfectly fine, but the program gave up on them and started trying other things. And the next thing you know, oh well. So now these all are going to bail if it hits a million. It's a 1,000,000 to 1 chance thing where if anything gets to the point, no matter what the score actually is, where it's like, oh, I've tried 1,000,000 things and none of them are actually better yet, at that point it takes that one and runs with it. And I can change that to be a much smaller number, but I'm going to leave it at 1,000,000 because I run these programs overnight, and that's probably what's going to get me what I want. And then the halt button down here is a whole separate thing. So this is a different logic function. Instead of this one has to be an AND, logic AND. And instead of that, we are checking to see whether it is less than 1,000,000. And then the overall one, which bails if it's going to crash, is less than 16 million, because I checked and worked out that that was what it was. And then the generating button press is also part of that. And so now I update these in turn. If it turns out that I run this and it becomes very unlikely that it ever gets to that, I might change the 1,000,000 number to accept smaller numbers, because you could tell it, like, yeah, if you run anything and it goes more than 1,000 iterations without finding a better one, just take that one and go. And with that, we've got these updated. And now the program can run overnight. And if it runs overnight and has a really good end result, it will keep that rather than continuing onwards. I feel almost like where it was at, I could have left pretty much it running forever, and it would, no matter how good of a score it got to, it would inevitably give up on that and be like, I can do better, can't I? And then end up following a path towards bad options again. Quick answer to ORU music. Yes, this is. So where were we at? I'll tell you, we were updating stuff like this. so that I could do things like this. And run it. And then if it started off with a like 400 seed arena, it wouldn't simply get stuck doing that and never update itself again. So what this is supposed to do is, well, I mean, that's what I'm in the middle of talking about anyhow, so just listen up, I'll cover it. It's measuring how many of, and see, we've caught on. It's hitting a score where, and that's because it matched the size of the club. Or for a while there, it was hitting a score where it's measuring the density of the green, which is how often the reverb delays are stacking up on top of each other. It's measuring the spacing between delays, which is the stuff up in the top where it's a mustard color or a red color for stacking up very intensely. Spacings between are not very strong for 6x6s of this size because there's no space between the delays. It's just a solid mass. There is also a blue measurement which is not showing up right now. And I'm going to be replacing it with an entirely separate, I think I can use the blue rating, which originally, you can see it if I run the 3x3 quite easily, or the 4x4. I'll set it to 190. If I run the 4x4, you can see it. Currently, what the blue markings mean is the density of the reverb returns went up to this point and then reversed itself. So it's verbs getting louder, then verbs getting quieter. I think I can do better than that. The idea with that was having the reverb density not be too choppy. And it's fine, and it kind of mapped to room dimensionality, but I think mostly by accident. Because there's no specific measurement for room dimensionality and 3D-ness. That's just what I associated with that behavior. I think I can top that because it would also map slightly to amount of slew between these reverb densities. And I think the overall brightness of the reverb will map to the amount of difference between two successive reverb outputs. Like if I have a verb where the reverb output is generating a extremely dense section at like total number of delays amounts to 4024. So it's got a really strong output there. Addition of all these matrices added together. And then next to nothing at 4025, say. Well, that's a big difference between very loud and not loud at all. And you could see the different brightnesses of the green spots there. That represents which ones are more densely packed and which ones are not. I should be able to make this blue thing essentially measure slew between successive verb amounts, and which means that if there is a really dense one, like for instance, because it's not going to apply to the 4x4 very much, but if I bounce over to say a 190 in the 6x6, look at what happens with the green here. The green here is a much smoother gradient. That means that it starts with relatively few reverb returns, And then as they stack on top of each other, they get denser and denser and denser. Into the middle, it wraps. It goes from level to level. And you can see that there are little spots where there's a brighter green, but mostly it's this gradient, starting at quiet and going to loud. And that's what the blue is supposed to be measuring, except for we're not seeing it here because you can't, it's not showing up. And I feel I can do the same thing that I did with the green of measure out total number of blue or total intensity of blue and track what the slew is between these brightnesses of green. If I do that, it should work. Not only that, if I do that, it should not only work, but that should also be relatively equivalent to maximum amount of brightness in the resulting reverb. Because what I'm measuring is true peak of a particular section in my test audio. The numbers in the matrix are delay times of the householder matrix. So you set up a householder matrix with these numbers in the matrix, and that's what you get. In fact, it's a line of code in the box up here. You use const int delay u or whatever, and that gives you the numbers, and you can make your delay lines by going define an array of delay p plus 2 or something for a little extra space. And there you go. Then you have a little bitty array which will fit that many samples. And you just cycle through those. So I should be able to measure. Oh, or you are misunderstanding. A householder matrix n by n does have n power 2 delay lines, because that's what the matrix is. You can't simply have just one column or one row of delay lines. And you certainly don't want to have the same column repeated over and over again. No. Oh, then I'm telling you something that will help you very much in experimenting with them. You want a separate delay line for every little element in the matrix. That's what's going to make it be good. That's what we're doing here. And so I should be able to measure the difference in brightness between each of these, have that be what turns into the blue channel. And if I am correct, that is going to be able to measure the end result brightness of each of these before I do the listening test. I might be able to do a thing where it substantially improves the darkness of the resulting reverb. It'll be part of this process rather than part of the listening process. Because currently, it's running, doing all of these things. Back in the day, the only thing I was able to measure was the G channel, the end result. Then I added the R channel, which is actually showing as mustard colored there, which means not too repeated. Maybe I want to adjust that. But I should also be able to not only measure the see, there's the green. It's going through the entire thing. And just delays is the total array size of the combination of all of the delays. And it's set up so that the total array size is within the limit of what we can even do with this number of delays. Then we go through just delays like this, and anytime it's actually a zero space, we're counting up zero run, and then we're populating this new array, spacings. And that's what you see up top with the sometimes red and more often, I'm not sure if I'm happy with the mustard color. Why shouldn't it just be in reds? That's being done here, where red is spacings, and then this stuff happens. And this is going to be in all of my code except for possibly search 3. Let's check and find out. Oh, yeah. No, search 3 is being rendered completely differently. But not so much here. So let's go find out what that's about. I wonder if I can simply update all of these with exactly the same code and it'll work. I'm kind of positioning them so that I can see if anything is different. See, this one has to be a t+1, that one has to be a t. There's a small change there. All that means is it's based on whether or not the matrix itself is producing odd numbers or even numbers, because it's going to be one or the other. So that, then that's a t+1. And then 3 is going to be similar to the 5 here, except for it's not the same at all because we have a totally different algorithm. But I don't think we have to. So let's see, between display fill color black and synth, since that is graphics drawing code. And that is the same throughout. Mind you, I'm going to be maybe updating it, but search 3, totally different. But there's still display fill color black and synth. So if we take this now, and we select this stuff here, and we fill it in here, and then we run it and see whether it's giving me anything useful at all or whether I've just busted it completely. Let's find out. Well, it should be able to run anyhow. I'm not sure why it wouldn't. Nope, we got a result. It's taken forever, that's all. Oh, and it's claiming it's 1 to 6 milliseconds 2-seat room. That's far too small. And nothing is really being measured right, but all the same, maybe, I bet I know what happened. I was trying to run a 3x3 matrix at 750 seats. It's not really designed to go that big. Let's actually quit it and start it over again. So let's see if it does any better if I give it something more reasonable, like a 30-seater at 3x3. That'll make it more possible to see what it's doing anyhow. And yeah, it does appear to be drawing dots on the screen in much the way that I wanted it to. So, seems legit. So what's going on here is we're drawing all of these dots as needed, including the blue ones are that algorithm that I'm going to be replacing. The red and the mustard colored ones all the way over to the side. Those are spacings. So for that, what you want is a dense block of spacings that are not too bright. As they stack up on top of each other, they will become brighter. And we're currently just turning through a bunch of different examples, but that's fine because that means I can tell you what they mean. And we've also got very little in the way, I think these are being drawn on top of each other. That's why the blues are not necessarily deep blue. They are more along the lines of a cyan shade, and that's because there's a green being drawn in the same pixel as the blue. But the stuff over to the side, seeing more in the way of a stripe of red, or again, I said I was a little tired of the mustard color, so let's see what happens if I delete some of this. This stuff is the special case that causes that to make a mustard color rather than simply using red for the red channel. So if we go back to this again, I've now changed the code. And that's more like what I was thinking of. In fact, we can see how some of those reds are a darker red and some of them are a brighter red. Bright means too many instances at that point, i.e. spacings, but a lot of the spacings are in the same place. A dark color of red, or a lack of red like that, is optimal because that means, I think if it shows up as literally no red showing at all, that means nothing is overlapping at all. Every single spacing between one of those outputs is a different spacing. If they're all different spacings, what that means is it's not going to be ringy and metallic sounding. If there's lots of repeated spacings, it's probably going to be ringy and metallic sounding. It will reinforce the frequency at which that delay line is. So yeah, and also I see that it is, the things don't really overlap. Like if I had a larger seat number, then it wouldn't be overlapping with the spacings. Spacings is supposed to be in the first line, but a room that small, everything, it's like a shoebox practically. This is definitely going to be showing up as seemingly such a small room that it's ridiculous and not even useful. But I am happy with this change, so we're going to implement it everywhere. We're going to go right back to this again. And by this I mean what I had before I was making the colors be changed in that way. And I'll even run the other one so that I can see what that looks like on my larger reverbs. See where it's changing R and it's changing G, and it's all a matter of kind of finding additional colors to make out of a distinction between, and I remember what I did that for too. I remember what I did that for, but I feel I can work with it the way it is. See what it's doing now is it's showing any of the okay, random thought. Here's a thought. If I want to be able to see what's good, I could simply reverse that. I could have it be 100% red means, well, no, but that means it would show up literally across the entire top of the bar. Or other than 0. What it's doing right now is it's making the red dot disappear. They're kind of like warning labels, but I don't know if I like that. I could reverse it. So I think this goes to 256. So that's reversing it. Only problem is now everything is going to show up as bright red. And I bet you that's correct. I will demonstrate that now. With the exception of but I can do something to fix it. So check this out. Anything that has no entries will actually count as 0 here. Right, I don't use semicolons. This is GD script. Now let's see what we got. If this works, the whole thing won't light up in green, but there'll be lots more green. Yep, see? I mean, lots more red, sorry. That's all of the options that are not overly repeated. So what you want is the largest area of bright red you can get. And then stuff that is darker but not black counts as there are too many instances of this spacing, so it's not ideal. And I think that'll do it. So now the red channel, what you want to see is the broadest, largest spacings of for this, what you want to see is a solid mass of red showing up that's as wide as possible without any gaps in it. That will produce a sound. Let's do a larger one. That's a 300-seater. I can go a step beyond that. If we do a 2,000-seater, so watch this. See, there's less space to put those in there, but now that we're doing a 2,000-seater, spacings does all kinds of interesting things. Because it's spacings over a larger area, so there's more room for it. So if we have stuff where the spacings between the verb returns are all very regular, it's going to sound kind of metallic and stuff. The more spacings they have, the darker of a red it will be. And the more options for different spacings, the better it is likely to sound. So you're shooting for maximum number of red dots as a result of this. That's one of the metrics that we measure by, so it should at least be able to show that fairly well. and it's trying to maximize those continuous runs of red dots, like right up at the top there. Thing is, with a hull that big, you can't necessarily do every possible delay time. But bear in mind also, the delay times being shown as red dots there, spacings between echo returns, is a phenomenon of all of these delays being added together in every permutation, and we're literally measuring that. So that's why I run so many variations on this stuff. Like, I set it overnight running so that I go through millions upon millions of different options of these things. Because you see how different each one gets. Some of them, they're fairly closely spaced. There's one where there's a couple of major gaps between areas, and it just goes on like that. Some of them will have a spot like way out here, for instance, because there was a long space between adjacent reverbs. Some of them will be like there's one. We're basically going through and trying all manner of different options here. And probably the best sound will be produced. This is when I first invented this, measuring the spacings. It quickly delivered a situation where when this R factor was maxed out, and again, I've got those sliders there, I'd kind of like to change them to letter grades, because if I change these to letters, what I can do is build it into the output, and then you could replicate it. You could replicate the measurement. Like right now, you'd call this Z, Z, Z. They're all maxed out. You could set it to be somewhere in the middle, like this. That would make the R section be weighted more heavily, because the end score produced by that is at full volume, but the end score produced by G is smaller. And you probably want to run from the beginning with the same setting. But then this would be assigned a letter, and you could print it out over here. In fact, I have done before. It says like QZZ. Then you go and set the program to that combination of things again, and it should have a comparable tone compared to, say, if it was set like this. You should be able to measure what various settings are. And there are a number of things I'd like to experiment with around there. But yeah, what we're seeing up at the top here with these little dots, I can make them be easier to see. Or indeed, I could do a 5x5 matrix, and that will give me more spacings. Haven't updated that yet. Okay, so this is doing the other thing, where it's showing the ones that are bad as bright red rather than the ones that are good as bright red. So let's invert that now. I should be able to copy this over directly. Let's see if that's true. I'm going to say it probably is. I bet that's literally true. I can just do this and go from there. I'm probably going to want to do a var B, because we're not in a consistent point here. I mean, it's using the same thing, and using the letter T or T+1 is consistent across reverb types. Let's hit save and build. ORU Music, in order to answer your question, I would kind of have to say read my code, figure out how to do it that way. I've got a bunch of examples out there. They're on GitHub. I'm basically going through the matrix in two different directions each time, meaning that the stereo channels, even on a mono signal, can't ever be quite exactly the same, which is what I'm trying to do for spatiality in mono signals. Otherwise, if you have it be exactly the same algorithm each time, you can have a hard mono reverb signal and a mono input, which is not necessarily what you want. You don't want it to be like no wideness. See, now what were we going to do? We were going to look at 200 and we were going to look at a 5x5 matrix to see what that distribution looked like. And it looks to me like what it's doing is having more difficulty than the really huge one at getting a good spacings distribution. But it's still basically cool. And again, that blue I'm going to have to update. But here's how we do with this. We've now updated the display so that it will show a bright block of red when it's doing well. And if it fails to show the block of red, or it's broken up, or it's dim or absent, that means that's not actually doing well. And we're seeing a fair bit of dimmer returns there, suggesting that those delay spacings are over. Oh, right. For a moment there, that was a really good little block of red. That implies that there were evenly distributed spacings rather than having them be overrepresented. I think I can actually answer one of your questions. Inputs and outputs work for n squared. So what you do, a householder matrix, hang on a second, let me simplify it. I'll run it on the 4x4. You've probably seen a 4x4 matrix before. In fact, I'll leave it at 750 and we'll just fire it off and go. Ooh, beach ball of death, it's getting stuck. Hopefully it will be able to produce some kind of output. We'll see. There we go. It's just at a room size that is far too small. And I'm not quite sure why it's doing that. Bear in mind the code that makes this update the room size lives inside the search code. So if this one is not updating, that might explain something. Let's check and see whether quickly whether I have a problem here. Because in this code, in this is its own little script. Or actually, no, it's not a little script, but something in here is watching this number and updating this as you type new stuff. I'm not quite sure what it's doing. Oh, there's a signal. I guess it must be what it's doing is it's sending a signal. We don't actually have a script in that, but all the same, seats, target seats updated. This is the one that has the script in it. Yep. So we don't actually fire this one off directly, but when we go over to the scripts, tiny little script here. And this gets fired when I've changed the other one, and it's making itself be golden ratio, because of course it is, larger than what the other one is. It starts out with a larger setting and it chases it from there. So in here, I know this one, array size, target seats, that's going to be there for literally all of these, so that's fine. And I've got code in here that is apparently not present in the for. And it's here. So this is how it's adjusting that thing as it goes. So why is that not present in for? It's present in 5. Well, I do notice that it's a very different setting here, so maybe that's the problem. It apps edit seats -8, and that's so +2 and -8. Maybe we set it to be the same thing that the other one was, and then it will do what I was looking at to make it do. I don't know why I would care about this, but yeah, it's supposed to be adjusting on the fly. That's kind of what I'm doing visually. Honestly, it looks about the same. So tell you what, I was going to do a thing here. Anyway, run that. It's getting stuck. And it does appear to be updating. And we're hovering around the same size. So cool, cool, good enough to start. So now, regarding these delay lines, if you're doing a matrix, you need the full matrix in delay lines. So you need 4 times 4 delay lines at 16. You can't just do only 4. The matrix has to be 16 distinct delay lines. They are of these values. And you start with like these ones, you run these delay lines, and then you run these into each of the following ones. You do your 4 little delays, and then the output of each of those delays feeds into the input of each of the next 4 delays. And the outputs of those feed into the input of each of the next delays. And then the output of these go into the input of each of the next delays. That's how it does its thing. If it's a 4x4, the way that works is usually it is inverted. The output goes into, say, top corner. That'll go into this one inverted, this one not inverted, this one inverted, and this one inverted. Because the way that works, the 4x4 matrix, you've got this slice down the middle in which one of them needs to be positive and the other ones need to be inverted. That's how it produces the stable infinite regen thing that you can do. is if they feed into each other with those gain levels set up properly, you're converging on basically infinite sustain. Only the diagonal isn't inverted, exactly. Then when you go for, I should be able to show you just a moment where you look at yourself in the screen, and I go and find householder matrices, the picture. So here's where I took this and ran with it, because I found this, you see. So there's your 4x4 right there. These are the rules for the 5x5 and the 6x6 that I'm currently using. The diagonal ends up being a little bit larger. Interestingly, the 3x3 also has its rules to it as well. You can do this. And in fact, I am. But with the 5x5, most of those end up being -2, but the diagonal is +3. And with the 6x6, almost everything is back to -1 again. In other words, just invert it and go. And only the diagonal is +2. And they work, except for that, see how this is a half of this? I think that's overall gain trim. Coming out the output and going back into the input, the overall gain trim has to be 0.5. And then this ends up being 1/5, and this ends up being 1/3. And that's how you get the unity gain going back into the beginning of it again. But this is the internal math. The diagonal isn't inverted with the 4x4. And likewise with the other ones, these are the gain settings you use. I don't know who this was or how they came up with this stuff, but it has proven to be exactly what I needed with regard to building these reverbs and things. And so I'll quit out a preview, and you end up generating stuff like this. Now here's the next step. 4x4 matrices aren't very impressive looking. In fact, the only way I've been able to display them very effectively with this is by letting them clip through so that the green is a lot larger. Although I suppose I could... Oh, sorry about that. You wouldn't have noticed, but I just quit out of literally YouTube. So hopefully my stream is still there. I will find out, won't I? Over to the stream, go to go live. This should be us, and sure enough, we're still there. And I gotta pop out chat again. And there you are. I hit quit on the wrong thing. Sorry about that. Got it back. I don't know much about Pure Data. Isn't that what Autechre uses? I wouldn't be surprised. Yeah, so let's quit out of this rather than quit out of... I mean, I guess I didn't quit out of OBS at least, so there's that. I did not lose the stream. I lost my window on you and my window on how the stream was doing. So here's the thing. We can do this. That's a 4x4 matrix, right? So in our displaying, we're generating R and G and so on. So technically, this is the same code throughout, but maybe it'd be fun to see things more clearly this way, i.e., see, When you have a number that is less than 1, which is what this would be, where the max is going to be 1, and you square root that, it makes it closer to 1 rather than closer from the other direction. And then we multiply that by 256. So now we should have a 4x4 matrix where rather than being almost a total blank, we should be able to see the green dots better this time, if it works. Yeah, I'm going to say that's, yeah, seems legit. 4x4 matrices are not very dense. I'm just saying. Anywho, let's try that with some of the other ones now. The 5x5. Might as well do the 6x6, because why not? And the 3x3. They do match now, that's nice. So now if we do our 6x6 matrix, it should be a more solid mass of green, probably without many features to it, and indeed that's what we got. One thing I like about that, look at that. You can see the interactions of the brightnesses much better now. That's pretty cool. That's distinctly cool. See? See, we're iterating through these different things and we get this complete texture that is transmitting through the area of maximum density, but it's kind of enhanced at the quieter sections too. Neat. I like this change. That was just a random whim, and yet all the same, I think that's a very good change. Because one thing about it, any little pattern that you see there is likely to be heard. Anything that's not a featureless green wash, any pattern that shows up, that's going to be heard. That's going to be audible. If it's a regular pattern, that probably sounds bad. If it's a deeply irregular pattern, where it just sounds sort of like cloudy or texture or something like that, that's probably good. So this bit of throwing in the square root there is a nice variation because it's bringing extensions of that pattern out much more strongly than I expected. The appearance of things, whatever texture that density of green is, I didn't expect it to jump out as clearly, but it totally is. So again, what you're shooting for is not regular patterns, but probably a noise-like texture. Because I'm not sure pure regularity is desirable either. But that remains to be seen. Because here's the thing. I could generate stuff like this. In fact, that's literally what it is doing. It's generating it so fast that it'll be a long time before it settles down. But as it goes, and it's going to be trying to hit its best score, and then the more it goes, the more able it is to stay on what's the best score. Right now it's still in sort of the shakedown cruise. I'm expecting to run anything like this for about maybe 10 minutes before it really settles, because what it's doing is it's dialing in the general area of what's the range it wants to operate in. And my hope is it can do that without getting stuck anywhere, so that it can run for a longer run and come up with what would be good options. See, and there it hit something where it's sticking a little bit, but not for long. And then it's going to bounce around crazily for a while again. But that's how it do. That's how that one does. And what I'm seeing is these patterns, these textures in the green there, where I think I think first of all, if it is a very high contrast texture, that's going to be brighter. It's going to give me end results where the high frequencies carry through the reverb more, because it's larger contrast between loud results and quiet results in the pile of echoes. But if the texture is not patterned, that's probably going to be the best of all. So then the next stage, see, that was very briefly there, that was one that was pretty dense with texture. It was high contrast, but it wasn't large sort of ripples. I think there's another one up, and we are still bouncing around madly. See, that's what you get for making the varying factor. So what would happen? Whoa, up a second. This part here is the same for everything. And it's this algorithm. Seats minus get parent blah 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 blah. But when I'm running an enormous delay, when I'm running an enormous reverb with many seats, it's spending forever even settling. And that's because if I have a large number of seats, then the difference between that and the target is also going to be a large number, meaning that this could get messy. Doesn't have to, though. Let's do a little... See, I can make one of these. So, now if I do that, I can use that value here. If I can type at least. And that should now work. But here's the thing. Oh wait, have I done that wrong? That's weird. What's going on there? Oh, I didn't capitalize, that's all. There we go. That's assuming maybe I had better not have that be the same name as the name of the node. I mean, I don't know if it'll fail to work, but I'm suspicious of it. So let's have that not be the name of the node. There. So this is now the same thing as what it was before. But what I can do now is this. Now that's going to end up being too... Oh, look at me making the same mistake again. So that's going to cut this down to being only 1 rather than the full size. But it was too twitchy anyhow, so maybe that's fine. Also, why shouldn't I move this to the same place that it was? See if we can do that. And that's going to go here, which it makes sense because it's right next to this other one. And then we literally, oh, have you, for heaven's sake, did I not? I didn't delete it, that's all. We delete that one, then it's fine. And then plug this in. This should give me results. In fact, it should give me the results I want. I'm not entirely sure about that, though, but I think it's probable. There, and now they say the same thing. But now we've scaled everything back. What that means is it's going to be less unable to settle to anything at really large room sizes. So how true is that? Here's the 750. So what we have just done is changed it to be, and see we're far from 750, so it is continuing onwards. What should happen, if I have done this correctly, is it's still chasing after new settings, but it's a little more willing to stick on something and stick with it for a while. But it'll take a long time for it to really start sticking with what it's doing. And that's because we're now scaling the difference between seats and the target. We're scaling that to the size of the hall. Otherwise, if we picked a really, really, really large hall, it would just be so far off that it would be impossible to ever settle. But now we've got it sticking a little bit. So that pattern that I'm looking at there in the green is not too bad. It's a little bit regular, but it's working harder to come up with something better. Although I will observe that the fact that it's settling on an 841 seat hall when the target is 750 is partly why I did this modification in the first place. So let's quit out of there and run it again with the pathological test case that forced me to go to all this trouble. Oh, actually, no, I could do 99. So what was happening was I was trying to do variations that were about 200 seaters, like rooms that were not really small rooms, but confined rooms, club size, rehearsal room sized rooms. And I was trying to start from 190 and run a bunch of variations on the program. I guess I can do that. 190, 191, 192, and so on. Run a bunch of different instances and have them actually try to find a new output. And what was happening was the room size they settled on was enormous, and they just got stuck. So we're going to see whether this is doing the same thing that it was doing before. I do know what to do to fix it. And yep, we are back into the problem that we had before. So this is what was happening, and this is why it's bad. What we're looking at is more or less the first one it even tried. Happens to be a 336 seat club, and the attempt is to smush it into a really small space. It is trying a bunch of other options, hovering around the right size, but since the bunch of other options are a smaller room, they are overlaying on top of each other much more intensely, so the end result score is never even close to this 336 seat club. This happened with like every one that I ran. It was not a fun morning discovering like, oh wait, that seems kind of funny. What are these doing? Hang on. Every time I run it, it takes the first one and then never tries to do anything else. Because every single one that it hit was not as good as the example that was far, far too large. So yeah, we've replicated that problem. However, there is another possibility which might be a matter of solving things. Firstly, we can have that be like that. And we'll start them as the same. And secondly, we have this little script in here for updating it. This was simply a factor of making a change and then having it be propagated to the target, which then gets updated. So the first thing we do is we make it be a much larger target, but that's hurting us this time. So what would happen if we didn't do that? If we did this, now we're just echoing whatever changes we make in our target and applying it to the one that gets to change. What now? So what's happening there is now if we update that, the one that chases never gets set to 6 times the previous one, which might mean that it never gets set to an unreasonably large setting. I'll put it to the 190 that I used before, which might mean I don't end up with an unreasonable result and it's able to function. But we'll find out real quick because it's going to try now. And the first thing it does is get stuck. That's probably why I had it go to a much larger setting. It should be able to do this, but it's just finding it a little difficult. Also, I'm going to have a sharp eye for whether this sets itself to like 10 or something crazy like that. Because it's like the Chesterton's fence idea, where if it's doing something that seems to make no sense, maybe there's a reason. Maybe the reason I did this is because if it's just the same number, it goes crazy. And instead of having it be multiplied by 6, it should be multiplied by something not as big as that. Honestly, I'm warming to that explanation because we're definitely stuck here. Hmm. 200 times 3 makes it be 600. Just in case we don't even edit anything, hopefully it'll still run. So now rather than times 6.18 in classic Airwindows mimetic golden ratio fashion, we're doing it times 3 and seeing what it does. That probably has something to do with the troubles I was having. Like it would get stuck because it was, yep, see, and now it's fine. And in fact, it's hovering at about the right. So I guess that implies that I'm not too far off the mark there. It's definitely quite happy to chug along now. One side effect of that, however, is now that it's hit a perfect score of exactly I'm a little suspicious of this now. I might need to make it a little more sophisticated. Here's the thing. If the... nope. Actually, it was able to find something else. So when the seats and the output there don't match, it's leaving a little space for finding a better one. If the seats and the output perfectly match, what's going to happen is it's going to pass through the score exactly as it was. That's probably fine. I just saw that it perfectly matched, and yet it was still able to find a better one. That's the desired behavior. So we're probably fine with that. See, it's not keeping perfect lockstep and leaving the first thing that it found. But it is at least sticking on this one for a while. And again, the goal is to get a lower and lower score as it goes. It's just that in order to do that, it has to actually come up with a better option. However, since that seems to be working, we're going to have a quick look at what it looks like when we give it a very large score. Is it going to be kind of stuck ruminating for a long time, or is it going to fairly quickly come up with something good? 6x6 again. This time it's a 3,000 seater. Cool. Alrighty. I am liking the slight changes that I got out of that. The only thing that is arguably questionable is the fact that if it perfectly matches, which is harder to do with the large arenas, I think. If it perfectly matches, then it really has to come up with something good in order to bump the score down and replace where it's currently at. But this is looking like we're in the zone for being able to run this over extended periods of time and have it come up with better options when they're really better, not get stuck on inappropriate settings like a seat size that is far too large and gives a inaccurately low score that isn't representative with what it's trying to do. And there's a further test that I could do than that, though. Like, this is looking pretty good. I am fairly used to the idea that you have to wait around for a while in order for it to replace. Like, look at the texture of that green. That looks kind of noisy, as it should. It is supposed to look kind of noisy if it's an actually good result, because we're also seeing the little red dots up at the top. The way I've currently got that set up, the distribution of the brighter red dots is all to the good. That means that there's a lot of non-repeating delay spacings showing up in there. And when I first started experimenting with the delay spacings and going for that, that's when stuff started sounding physical and real, rather than, it's a fake reverb. And we've got another update. And the other update also looks kind of noisy. It's supposed to look kind of noisy. See, if we look really closely, we can see that there is this bright dot in here. But mostly it's not bright dots and it's not showing up in a pattern. There's a slight sort of diagonal pattern there, but that's not too obtrusive. Ideally, I think the perfect result would be a featureless green pipe with no texture. And the second best result would be featureless green pipe with like a faintly dithery noise texture with no discernible pattern in it. That's how I think a good sound would map onto this display from what I've been doing working with these. So yeah, that is a very large reverb and seems to be following the same rules as the previous ones. So one final check. I'm curious as to whether this will work. It's possible it'll just crash. We'll see. If I do a 90-seater, which is too small of a room for a 6x6, and yet I run the 6x6 on it anyway, does it just hang, or does it give me a result of some kind? See, we're starting with it just hanging, but that's probably fine. Ah, bingo. So it's probably going to hang a little bit here, but see, we got the low-res equivalent of that featureless green pipe, which is a very smooth progression from dark to full brightness green, back to dark again. And we're even running fairly smoothly at this stage. We're not getting the beach ball to death anymore. So it's kind of a pity that we hit that first off, though, but I think there's probably no way around it. This is going to be too small of a room to sound good. It will sound kind of like a closet. But all the same, it's doing pretty good, and although it's running very slowly because of all the overlap, I'm pretty sure what that's doing. We are updating often enough that it's trying new, there's the beach ball, that it's trying new things, but then it is also incrementing this, meaning that it is accepting that and trying harder to, it's looking like this works. So we have one remaining thing. I'm also approaching 4 o'clock. I'm wondering whether this is a time for me to like defrost my taco food and stuff. Because there's a further thing I would like to add before the day is over. See, it is working. It's able to update, and it is also able to start over and find a new score. Although this might be its way of, like, see where the score is 161,648? That number might end up just increasing, at which point it'll start trying other stuff wildly, and it'll lose all the progress it had made. But the longer this runs, the less likely that is to happen. So yeah, that part appears to be what I would describe as working. Interesting that we look at the matrix itself and see that we're using like all of the low primes in one place or another because we have to, because this is, I bet that's why it freezes too. I bet you that's why it freezes. If you tell it to be a really small arrangement and then it is unable to stack up that would do it. That would do it. That would explain why it freezes up and completely fails sometimes. In fact, that might be what's stalling it out now. In order to generate a 90-seat room, say, as a 6x6 matrix, there have to be enough of these that are small numbers. And it's being prevented from doubling any of them up. Which is another question entirely. Back in the day, I was running a thing where some of my best results were doubling some of those up. So I think time for a quick experiment. here's where we do that. From the top, calculating out room size, getting these amounts, dupes, and while dupes larger than 36, delays resize 0, and then we're kind of going from here. This is where it is forcing room size to be smaller. If I set all of these to be room size times 12 or whatever, it will automatically just freeze up and be unable to operate. We are, in fact, forcing most of these, like if they were all room size times 4, that forces all of the options to be at least 11 or more. Like if room size starts at like here, and it's picking these based on what the size is, but it's starting at like 11. It's not doing anything smaller than that. But then room size times 4 means that all the other ones have to be at least 31. If it's a 6x6 matrix and it has to be smaller than a certain size, it will be unable to come up with anything that works. So I feel I have an update to make here. Namely, heck with that, start generating potentially more of your little tiny ones, and we'll just go from there. Might be a little weird, but might just work. And I think I might be able to copy paste this so that I don't have to manually do every single bloody one of them. But it looks like we're doing 36 for these. So, E. Because when it absolutely freezes, it's because the conditions given by this are incapable of producing a room size that small. After a room size does start with something, so we can at least make it a little bit easier on it. Technically, I could include even smaller ones. And I range doesn't have to start with that. That could be a number. Well, firstly, let's see what we did. Can you get started easier now? Still freezing up a little bit. This is the condition under which it has a lot of trouble. But look, see what happened? We now have much smaller ones and it's moving quicker now. Because it's trying to do this tiny room size, meaning that it needs to maybe resort to smaller numbers. Yeah, I could bail out, but I could also just let it try doing its thing. It's definitely running quicker because some of these room sizes involve incredibly tiny delays. A delay of 3, that's very small. But it's all part of this giant equation. It's all part of using the 6x6 matrix. So yeah, that's probably fine. I don't know whether I can make it be an even smaller room than that, but you know what? One way I can find out. Can we select this? Is it going to be 0 seats and cause it to crash, I wonder? Oh, I think maybe that's what I did by mistake. Oh dear. Well, maybe we'll just quit it and start over. Yeah, I think it thinks it's 0. It hasn't even updated yet, but it's like, no, I can't do this. I can't make a room size of 0. Let's see whether these have similar conditions. Where are we at now? Well, it goes to number 25. Tell you what, let's just copy them up to number 25. That should work. And then there's a further twist I intend to try, but for now. And then this is going to be a 16, presumably. Sure is. It's forced. Maybe this is why this one sometimes has problems. Well, 0 to 16. Copy. Paste that in. It's just part of how we initialize things. The stuff that we're doing is specifying what the numbers can possibly be. And then lastly, I guess I go 1 to 13 is how that one works. Far be it from me to wonder why. We'll just do it and see. Bada boom. Now notice where it says, while dupes larger than 9 or 16 or interesting, that one's, well, no, 25 or 36. So I can change this and allow duplicates, which might help. If I do, for instance, well, dupes larger than 38. Now, hang on. Now I'm trying to figure out whether so is that going to run, or is that going to immediately crash and not work at all? I might be going the wrong direction. See, the challenge here is it's drawing these out, but it's not necessarily easy to see whether I have duplicates at all. I think I may have set it up. Okay, let's quit out of here. We'll try the opposite. So dupes larger than 36. What if it's 34? What do we get then? Is that going to force us to have duplicates, or is it just going to crash and die? We'll find out. Signs point to it forced it to crash and die. So it can never actually finish. Fine, fine. We learned something. Actually, it'll be easier to see on this one. So it's counting. This mechanism is checking whether there's repeated numbers, so there's that. So I think I can force matters. Whoop. We made this larger. That's actually a simple comparison. Technically, we could hold out for well, hang on a second. No, if we do that, then it never generates anything. So how about a little undoing? Let's see if we made it do the thing. That's just a kind of guesswork, but we might find out. We will firstly see if it's able to generate anything at all. Oh dear. Okay, didn't like that one bit. We broke it. It's just zeros now. Somehow able to function, but still zeros now. Okay, so how about put it to dupes larger than 9 and see what we get from there. Also, is this where the zero is coming from? No, it shouldn't be. So larger than 10 wasn't working. This is probably too large of a room size, too. What do we got now? Does it at least start up faster? I know what it was when it was working, so I can at least go back to that. Oh, zeros again. Didn't like that one bit. Let's literally put it back to only what the previous one was and see if maybe my Randy range change here was what blew everything up. Because that shouldn't have blown everything up, but I think it did. Maybe I have a minimum room size. Going to need to do a couple of quick checks here to see whether everything is intact or non-functional. Do we still have the ability to generate? Yep, we do. No, it crashed. Hi. What's up with you? Didn't expect that. Is this just because I'm going for numbers that are too large here? I remember this looking different. I don't remember exactly what it was, but I remember it was not this. Does that make it feel any better? Because it did at least start that time. If we end up with numbers that are way too large, it'll choke and get stuck. Oh, no, we're still not happy, are we? Displays X. Do I have a bailout for that in any of the other ones? Not there. But here. Yeah, so we can sneak that into some of these other ones and then stop it from crashing in that way. See, it exists there, doesn't exist here. But here's where it needs to change. Much like that. And if we do that, it will not blow up. Looks like we even have a stack trace. Which means we can stop that there and try it again. This time, it should run without crashing. Yeah, I'm seeking different kinds of bailouts. I also think it is extremely amusing that I tell it to be 50. It's going for incredibly small room sizes for whatever reason, like a 2 and a 5. And so it's a 1-seat room. It's doing an absolute closet. And I'm not quite sure what it's up to there, but it's up to something. And these delay times are not long enough to make anything that sounds like a reverb. And sure enough, it's not attempting anything that sounds like a reverb. So quick little check on what if I tell it to be a larger size? Is it even in the vicinity, or do I need to update that too? I don't think it's very near being able to come even slightly close. I think we're a little screwed up here. Let's see whether the 4 is any farther away from that. No, 4 is okay. It's not great, but it's okay. Ooh, speaking of 4, it's 4:11. I have to step away for a moment before fixing that thing. So let me fire up some kind of noise. I'll be back in a moment because I have to get some food out of the freezer and get my oven going. See you later, Gabrish. So this is interesting. So I've got my oven warming up. I've got about 45 minutes or so before dinner. We're going to continue doing this. Listening to this music in the background just made me think of, like, no wonder I've had so much trouble getting music that I was happy with and going with it, especially combining the sequencers and things with instruments. Like there's a Rhodes going on right at the moment. Of course I was having trouble with it. Everything I've learned from making soft clock, like I can't entrain with how strict this groove is, because the kinds of sounds that I like are sounds with a lot of articulation and clarity to them, and those do not play nicely with sequencers. I need to play these kinds of sounds myself into the groove. I should be able to place them okay, but trying to entrain to background music where the sequencer is fully machine-based, it's like all well and good and stuff, but man, I can't groove to this. It's as rigid as Kraftwerk. Even if I can make the music play relatively and program it so that it plays chords like it does and do these various things, it's like, this is why I couldn't hang with this. Yeah, so all very interesting. That is a thing that I have learned. So let's see now. I just brought that up to work on each of these, so nothing should crash now. At least it's being told not to crash if it's got the wrong numbers. Oh, hi. Are we not able to build? Run, please. I'm going to restart Godot. It's not responding. Don't know quite what was the deal with that. All of a sudden, I could not run the program. Possibly on Thursday, I can do some coding from scratch and get into... I might have a start on it, but there's another program I'd like to do beyond simply this. However, for now, if I tell it to be like a 3x3, well, no, wait. The problem I was running into is that I could do these other ones, but the 3x3 was always tiny. I've just told it to be 400 in size. Am I even going to get anything close to that? No, I'm getting a 14-seat room. Except for now it's a 5-seat room. So that's way out there. So what's different? Also, one of the things I was going to do was experiment with this and figure out why it wasn't doing what I wanted. Again, I wanted to set this up so that you could have multiple of the same result, because that was working well for me in some cases. So from 9 to 15 should, in theory, make it possible for it to duplicate values. At this point, we don't actually care that it's not giving me sensible results. I just want to see if it gives me multiple values in here. It's running very fast, but it's not showing me anything. Maybe I'll try one of the ones that is behaving a little better. We'll put this back, grab another one of the options, like this one, for instance. Go to here, see whether we can get this to either give me or force me to have a duplicate value. So what's that going to be? The number will be higher. And you set it all the way down to 16, and it ensures that there are no duplicates of any sort. However, I feel like there was a setting in here where I was able to force there to be at least one pair of duplicates, and I don't remember what I did to make that happen. I don't see it here, though. I'm glad you can groove to that Death Outta Hell. My problem was I couldn't play music to it very effectively. Like I could, but then So let's see, we don't see any dupes there. So while dupes larger than 16, or less than something. So or is the vertical bars. That one. Thank you. So while it's larger than 17, or less than 17, meaning please keep on generating random numbers until I have exactly this result. Let's see if it worked. In theory, it will still work, but now one of them is guaranteed to be duplicated, and we have successfully done that. It is now 37, and it's now looking for another good option. And now it's found that, which is the duplicated one. It's going to be in there somewhere. 641 maybe? No? Interesting. Which one's the duplicate? One of those has to be. I've more or less forced it to be. I'm not spotting it. Maybe it will give me another example soon. Does appear to be in the zone. See, the point of doing that was that I was having an experience where a bunch of the ones I really liked tonally were reliably having a pair of duplicated values. I was allowing it, and then all of a sudden I listened to a bunch of them. I measured them. I was like, these are the ones that sound really cool. They all had duplicated values. Exactly one duplicated value. And I don't know why that would be. But it gives one furiously to think when you observe something like that. I don't see duplicated values here. I don't know what's up with this. Could it simply be that I'm generating more numbers than I need? Let's make many duplicated values and see what it does. Dum-de-dum. Got there. Oh, we're doing lots of them, huh? Well, now oh, there's one pair of duplicated values, but I don't see lots of them. I only see two. Point well taken, Debugging. Well, now hang on a moment. Dupes is not supposed to be the literal number that is put in here. That's supposed to be something else. Maybe the final one is getting duplicated too much. And now I'm telling it to dupe everything up a storm, and it's not actually quitting, so technically what I could do is just keep up in the ante. We can go over entries 1 to 16. That's actually 0 to 16. So I can have it match this. And then force it to make that many duplicates, and let's see what it does, or if it can even do anything at all. Because in theory, it should be able to do it. There's 2 29s. 2 167s. Okay. So technically we can push in that direction. Cool. And it seems to be still happy to run. So I think, oh, and here we go. We've got 2 277s and 2 439s. Okay. I think what it's going to do is it is going to end up counting anything that matches. That's going to bump up the number by 2. So I can make even more of them match by having zeroing in on dupes of 24, and it'll probably still work. Probably, maybe. But there's this sort of mathematical quality about it where in order to have lots and lots of duplicate numbers, like the 31 and then 73 and the 173 and 389, those numbers have to be cranked up, and we don't often see like many different instances of the same delay. Instead, we have pairs of them. So having figured that part out, I think I'm going to want to dial it back to either 1 or 2 over the base number. And we're going to use this number, have it be range 0, 16. Let's see if that does in fact work. I wonder whether maybe I have to, no, it looks like it was okay. Oh, and you know what? I'm not seeing a duplicate in there because it would be 2 if there were 2 that matched. So there's your problem. Push it to 2 over the no dupes setting, and I should have a pair of every single one that I generate. And let's find out. Maybe the duplicates are that kind of thing. I'm not sure, but it seems possible. And it's certainly something that I observed and see. Also, interestingly, they would tend to show up in a sort of diagonal way, and that does appear to be what we're seeing. Of course, that's inevitable because of the way that I'm spacing them out. But yeah, so then the next thing to do, now that we are observing how this shows up, we don't get a visual representation of this very effectively on the 4x4 because it's not drawing that. Remember how when we were doing the 6x6 we were getting what looked like a green tube and it was very densely spaced? In theory, if this duplicating a value is that effective and works, it'll be visually evident in the end result. So the thing to do is, firstly, well, that's just weird. What are we doing? Zero to 9. Generate only 0 to 9. And or oops, less than 10. And now let's see if that actually works. Because it might not, but it might. It worked. Worked first time. Mind you, the room size is completely a million miles off, and it's struggling mightily to be, it's desperately trying to make something that works. So we're going to leave that alone. But at least that part worked. So 18, 18. And 26, 26. Oops. Same thing with we go from 0 to 25, and then range goes from 0 to 25 because we're referring to a... Anyways, we make it match up. Then, back to this. 37 is this one. Zero to 36, sure enough. And then we'll change range to 0 to 36, which I think is the way to address that. I guess you have a delays entry of 0. I'm not completely positive about that. In C and most programming languages, your arrays do have a 0 element. So I'm thinking that's probably fine. And now let's see what we got. We'll pick a larger one so that we can have it look pretty. This should generate a duplicated element. The question is where it's placed and whether we can pick it out. And it looks like we're heading in the right direction. All right, see you later, ORU. I won't always be working specifically on this, but there will be probably times when I am. And if I've done this correctly, there is actually a duplicated value in here somewhere. I just don't know which it is. No, it's 139. I see it right there. So, does the appearance of this green tube look like it is correct? I'm going to say it looks a little bit like it is not as regular as before, and that's probably significant. Interesting. Also, one side note. In this particular configuration, the doubled value shows up in one of the channels, but not the other. Oh, no, wait, hang on. No, it does, but not in quite the same way. In one direction, it applies at the final stage. In the other direction, it's hard to figure out. It's hard to figure out. And here we've got another one, also with doubled numbers. I don't know what the new doubled number is. Yeah. The diagonals phenomenon showed up. Well, that last one wasn't actually a diagonals. This one may possibly be, if it sticks around long enough for me to be able to see where the doubled value is, because there's a thing. The way I've got it laid out, it's now actually going to place the doubled values in specific places, which might be relevant and useful. It might be placing them in a good way. I'm not spotting the doubled value, but I bet it's in there. They're very closely aligned values. I don't see anything doubled, that's the thing. And I would have assumed it forced there to be one. Where are you, doubled value? You should be there. Although I don't know. I mean, if it comes up with a great one and it's not a doubled value, should I be complaining? One of my initial assumptions was that you had to not have any doubled values, that it was guaranteed to be bad and wrong. Or am I updating it correctly? That said, I'm liking the look of that, but am I updating it correctly? Here we are, we start here. Oh, no, I'm not. It went from 16 to 18. It would go from 25 to 27. There needs to be 2 entries in a doubled. That's why. So let's see. So 9 would have to go to 11. Yeah, a doubled value shows up twice. Otherwise, it's not going to... See, it went from 16 to 18. So all of these other ones now need to be updated. 25 to 27 and 36 to 38. That should work. Got there. And now let's have a look at this and see if it looks any different. Now that we're pretty darn sure it's going to produce a doubled value somewhere, 577 in this case. I don't know about that one, but then I was going to make it be a larger... We're going to go full cylinder with this, right? Let's do a 2,000-seater arena with the doubled value, now that we are effectively getting the diagonals double value. Don't know which one it's going to be, but there will be one. Interesting. I feel like that's breaking up the regularity of that texture-looking quality to it. I'm not absolutely certain. But we got a doubled 2053, which seems about right. It's on a diagonal. I'm not sure what that... I mean, the relevance of that, hard to tell whether that means anything. But we've successfully gotten a good score out of it. Maybe we'll run with this for a while. None of the previous stuff that I've done had that the doubled value thing going on, because I wouldn't have guessed it was that time when I was showing the reference matrices, and somehow I had evaluated them and been like, this one sounds amazing, this one sounds amazing, this one sounds, wait. One of those, the scientific discovery noise is never eureka. It's never, I successfully conquered the problem and I have solved it. That's funny. That's the one you watch for. You got to watch for those ones where like, huh, that's weird. Because those ones are the killers. Those are amazing. Well, seeing as it's that happy with this, let's run it again, just so that I can see it. We'll call it a 3,000 seater this time. It may or may not show me several of them, but it will at least show me the first one. That's guaranteed to have a double value in there somewhere. So what does that look like as far as does it look like regular patterns or not? And I think the answer is when there's the doubled value in there, something about it stops looking like a regular pattern. And that's interesting. You can break up a pattern by screwing it up or perturbing it in a way, and that's like, yeah, other irregularities somewhat controlled, or adding in distortions, or having the perfectly smooth and according to the numbers, you throw in a monkey wrench in there, this could be just the thing. Then it's going to become a matter of like, how well can it do in coming up with, here's another one. That also does not look like a regular pattern anymore. Interesting. Like it kind of feels like there's a regularity in there, but Also, I bet there's no way to tell whether a doubled value is tripled. I don't think I have that in the tank. But it would sure be funny if I did. Or it could be done purely at random. Maybe I don't have to, here we go, there's another one. Still is not looking as much like a regular pattern as it has been this entire time. This is very interesting. We're all looking at this together, and I mean, if you're used to video games or video game making or something, you've probably done things like seen textures before. Look at things like a grass texture, see whether it appears to be repeating. There's a quality here where it does not look like it is the same thing. I do wonder whether I could speed up this process by simply not doing as many random generations. Okay, so we're at 3,000, right? We're doing roughly 116 or 117 per iteration. If I can speed this up, well then, I can speed it up. Probably don't want the doubled values to be the tiny ones. Hang on. That was useless. So to do this a different way, what we would do is this. And let's see. We still get a random one to pick, but if we simply append it twice, it automatically will have a doubled value, and it'll be sorted. So that speeds this whole thing up enormously. Let's see whether we can apply this. Not even use that. And then these all need to be, oops, well, that didn't work. All need to be one step over. Fortunately, I'm fairly comfortable with doing that. It's making a loud noise, but I'm sorry about that. Can't help it. And that should produce exactly the same results as doing them with pure randomness and then essentially forcing measures. Let's check it out. We'll go 2000. Doubled values, where are you? Because now they're pretty much guaranteed to be there. I have compelled. The power of random numbers compels you. I'm just trying to eyeball them to spot where they are. No, it's 2017. It's the bottom corner. It's the largest one. Now it's no longer the largest one. But we are running, now it's 67. See, it's going to be any one, but we are sorting them and then placing them. No, we have, ooh, interesting. I didn't see that coming. That's 367s. And I know why. We've just stripped out all of the code, ensuring that it can, oh yeah, we got lots of doubles, don't we? Okay, so I think maybe that might have been a mistake. It's easy enough to dial back. But see what we've got now? We've got a cajillion doubled numbers. We have the ones that we forced to be there, and then there's other ones that are also there. That code was originally there to stop there from being doubled numbers. And I think if we have too many duplicated primes in there, we're going to start losing the benefit. I'm not absolutely certain about that, but I have a funny feeling about it. I think I only want one instance rather than lots. So I think it's time to find out how good the Godot undo function is, because we're going to undo right up and more. Interesting. So there's 261s. Two 1979s. So that's two pairs right there. What else have we got? I'm ogling these and trying to figure out whether there's more than two pairs rather, of doubled up numbers. Because I do not trust that having lots and lots of pairs of doubled up numbers is going to help. It feels like that is not going in the correct direction there. I mean, one thing about it though is what I am looking at on the screen, that little green pipe with the texture on it, is literally a visualization of the reverb. And we've got another one. How's that one stacking up? 2 347s, 2 1877s. So right now, we're forcing matters in that we always have to have at least one doubled prime. Oh, no, hang on. 647s. We have, and 347, and 82. Okay, now we have 3 pairs. I don't trust that that is actually a correct way of going about things. Although I will observe that they look to be arranged in little diagonals. But then that is actually more the way that I distribute them, which is not randomized. That's purely mechanical. And look, we're starting at another one. What's that one got? 2 1667s. Okay, so this is the newest high score, and I think this only has 1 pair, which I can easily force. Oh no, I stand corrected, I think. No, I stand corrected. There's 29 and there's 1667. Yeah. And 211. So I think this is going in an undesirable direction. I do not trust that all of the delay values can be the same and it's good. So we are in fact going to undo past the point where we made that happen. And then what's the next one? Oh yeah, that's part of it, isn't it? So a little redo. So we can do that and then do the while, so we can automatically, we don't have to grope around for having a doubled one. But we can make sure there's only one. So copy, and we'll apply it here as well. And also here. And just for laughs, we'll apply it in this one, just because it's funny. Might not actually do anything useful, but we'll see. Boop. And boop. Save. And let's see, over here. Just like that. And save you as well. Like that. This will make it run faster because it's going to be overwhelmingly more likely that it'll pass through the first try. It's not going to have to grope around being like run until it finally gets a doubled one, because we default to having at least a doubled one in there. Let's see if it works. We'll do a 4x4, see what it does. Well, for starters, it stalls, but let's see if it runs after that point. Oh, are we stuck? Are we stuck? It's almost dinner time. I'm not sure if I wanted to get stuck here. That should work. It's supposed to work. I'm a little puzzled. How about the 5x5? Does that work? Have I missed something somewhere? What's going on? You are not supposed to be getting stuck. The 6x6 was supposedly working. What's going on? I was running it at a much larger size, though. Yeah. Oh, I'm feeling it. Okay, so that's super no bueno. I don't know what went wrong. I don't know what I did wrong. Append this. So that should have worked, but this part didn't. What if larger than, oh, maybe I've simply missed that. Well, let's see if that made it any happier. Also, I can bump it up to the larger one, which it seemed happy with. That's the one I was looking at. Do we get a result? No, we don't, do we? What's going on? You were working before, you crazy thing. You gave me a set. What's going on with this? That should work. I don't understand. So let's put it fully back to maybe I can sort of rephrase it. So if it turns out we can't do this, then this should give us some kind of result, and it should work. Otherwise, I'm still missing something. Nope. Back in action. And presumably finding exactly one double, because that's what I told it to do. I am trying to spot it now. 23. Okay, so far so good. So in theory I can do the other ones and that's fine, but it didn't like me doing that with it. So if instead of 35, that's going to be a randomness, so that in theory should produce a double quite directly. Let's see if it worked. Still got a beach ball. Bleh, I don't want it to come to this. No bueno. Well, what if we're on 35 and it's trying to append itself? In that case, we tell it to append delays 34, which is going to be the value that's in delays 34, which is an integer, so that should be fine. And is it any happier if I do that? Should find out pretty quick. Really? I am disappointed. What happens if we append it again? Could that be the secret? Okay, we got something. I'm not quite sure what that's about, but it got somewhere. It's updating. And it's 6:47 that time. And now it's trying for another. I'm going overtime as usual. Well, I want to do this up properly. We're appending a couple and seeing what it does. Let's try it again. Because somehow we got into a zone where it was capable of choking and not being able to function. But now it looks better. I just don't know which one of these values is the dupe, but there should be only one now. And we're updating fairly quickly. I am trying to spot the duplicate values as we go. A 41. Oh, it's triplicate. That's unexpected. Okay, so if you can run so happily doing that, what happens if we don't try to double add? It should have bailed out. It shouldn't have done that. It shouldn't have left 3. So if we don't double add, just hit play without doing anything. And what's happening is we are getting stuck. I don't like that. Well, this is all literally just an optimization. It's meant to make it run faster. If it is making it freeze and die, that is doing it wrong. For that reason, I'm going to bail out of that and go back to what is presumably a slower way of doing things that was at least reliable. This. And I never optimized any of these other ones too. 0 to 23. Maybe that's what's going wrong. So 0 to 23. Oh no, I fit this into these, and now I need to back it back out of those. I had done all of these this way. Oops. Well, easily fixed. Maybe it'll make it more random, the fact that I have to grind through these extra ones that I don't want. Come on, select please. Can you please select? Thank you. So 36, then 25, then 16. Man, I so wanted to do that experiment with the blue channel, and it just ain't happening. Probably what happens to me when I drink the extra cups of coffee. I don't want to let go. I don't want to stop the hacking. Also, there's like literally, well, I say there's literally people here, and then 3 of them log off instantly. You don't say. All right, let's do a little quick test and see whether it runs on, say, a 2,000 seater for a 6x6. Signs point to yes, that is. And in fact, it's updating nicely and running good, and the duplicates are going to be in there somewhere. It was running pretty reliably that way. I may not be able to spot it instantly off the top of my head, but I bet it's there. Oh, 41. I spotted it fairly easily, all things considered. And then we'll try the 5x5 and the 4x4 and the 3x3. And go. In this case, it's the 757 number that's doubled up, which is probably significant. There's probably a meaning behind where those things land. Oh, and we're bounced to another one. In this case, it's the small one. It's the 11. Cool. Still looking good. So I guess I'm leaving that the way it is. The fact that I'm having to run multiple, I guess when you do that many random numbers over a fairly limited sampling, getting the same one twice is not that unlikely. probably more as likely as not getting one repeated. It's like the birthdays paradox, where you get a group of people that's like 16, 20, 30, something like that, and the chance of two of them having the same birthday is actually quite high. It's going to be one like that. So let's see, we'll quit out of here, we'll test the 4x4. Also in 200-seater. And then it's been a while since I've dealt with the 3x3 for any purpose, and so it's probably okay for it to be super broken. I'm not actually using it. I may want to fix it, but that can be another day. And here we've got another double. So that seems legit. It doesn't have the visual richness of looking at a giant reverb made using a 6x6 matrix, because that's so textural that you can kind of pick up details. This, not so much. This, you just sort of hope that that sounds nice, to the extent that 4x4s can even sound nice. Because I'm a little skeptical about that. I've done a lot with like clear coat and so on, and I always found it really frustrating. And then here we are. That's supposed to have a doubled value, but I don't see it. No, I see it. It's the 643 in this case. So yeah. Maybe the fact of it being a householder matrix changes the relevance of there being repeated numbers in there. I don't know, but one thing about it is I'm measuring it according to the householder matrix, and so if there's a way of it being arranged that's not good, that'll show up by delivering a lower score. Anywho. It is possible that what I need to do is come back on Thursday and we'll keep tinkering away with this, because there was that stuff I wanted to do, and I'm not willing to just continue to do it on stream skipping dinner. So it's time for me to go and have my tacos. But thanks for hanging out with me while I was doing all this. We got some stuff done. I have a good feeling that next time I run a batch of these, like my range from 190 seaters to roughly 200 seaters, I'll run a batch of example reverbs and might end up with some that sound cooler than they were sounding before, even if it is a fairly subtle thing. And that's what I'm after, so hopefully it's been worth the hanging out tinkering with this stuff. Hopefully. Anyhow, I'll talk to you later. Bye-bye.